need Anticheww. Okay, well, let's post. And where is it? Member media. Shit. Okay, I forgot this is slow posted. I mean, I can edit it. Nice. Okay, cool. Start the mic gain. Is this? Hopefully, this is loud enough. Well, still no viewers, so let's see what we got. Oh, just wait for people to stream in. Till then, do some work on Boston. So, gonna save this as. All right. Template. This is gonna be the wing keyless bottom row. Hello. Not sure who showed up, but so I'm very new to this whole Twitch thing, so I don't actually know your usernames or anything. But yeah, I'm going to be designing a case for Gondo's 65% PCB. I'm just gonna wait for some more people to show up on the stream before starting. In the meanwhile, I'm doing some plate work on Boston. I'm adding split space and wing keyless to the plate. So I'm gonna be doing that for a couple minutes until I guess some more people show up, and then I'll get started designing Gondo's PCB. I guess yes. I'm very new to this whole Twitch thing, and I'm not like I don't really know how the controls work that well, so not really sure how to switch cameras or anything, so sorry about that. But yeah, so I'm gonna wait for some more people to show up. I'm gonna do some Fusion CAD for Boston in the meanwhile. Yeah, and just making some changes to the plate. So got some files from the plate generator, and then yeah, cool. I'm just adding wing keyless to the bottom row because that was requested. So these files I got off a plate gen. This is not working. It's okay, Fusion. Okay, that's why I need to create a sketch and then insert DXF. Wing keyless bottom row. I accidentally put the shift key in there. Whoops. That should be fine. Extrude this and save it. Alright, well, if no one else shows up, I'm probably going to start in let's say 5 minutes or so. I'd post to all the design discords. Yeah, but if you ask questions in the chat or if my mic's too quiet or anything, please let me know. Very new to this whole streaming thing, so cool. Okay. So where's the main plate file? This is the main plate file. So we're going to add the templates for the split space and the wing keyless. This is generally how I like to design my plates. I use a plate generator and then I use them to make these templates that I then use for extrudes. So first we're going to do a join so that these are in the right location. This is why I have the escape key in these templates. Usually join things to escape. So let's do that. Let's raise it a bit. Should be what? Offset 1.5. Okay, and then that's for split space. So let's add those cutouts. So create sketch. I'm gonna project off this, and then it's done. Hide the split space. So I'm actually gonna do it partially. I might just straight edit the KiCad plate file. So this is an FR4 plate, so I actually have a KiCad file for this too, and then in addition to the Fusion file. I could make a new KiCad file for this new plate, but I'm gonna see if I can just edit the original KiCad file, and that might save me a bit of work. Because all these holes and stuff, you have to basically place in KiCad new. So it's negative 0.5. Wonder if I can see who's watching. Okay. Let's do wing keyless. So I'm gonna do the same thing. I'm gonna join this plate to here. It's backwards. I'm gonna flip it. That looks right. Okay, and then I'm gonna do the same thing. So make a sketch on the original plate. And yeah, if people have questions on what I'm doing right now, just yeah, feel free to ask in chat. It's gonna project. Should give me all the outlines for these cutouts, and then I'm gonna hide that and use a sketch to do a bunch of extrudes. Oh, that's okay. That's for that's a stab for the 7U. This and I think that's it. Oh, it's just wait. Oh, these are for the 1.5U. This really fucks up the plate, doesn't it? Let's do partial for now. Yeah. So this is gonna be really thin. So I'm gonna have to turn this into like one big rectangle, which is kind of gonna suck. Hi. So I guess someone else joined the stream. So okay. Yeah. So there's 2 viewers, but that's fine. I'll probably get started on doing Gondo's stuff then. I don't know who's watching, or I don't know how to see who's watching the stream. So I don't know your names, but yeah, welcome to the stream. Okay, it's easier to edit the sketch by merging it or editing in Illustrator first. Yeah, I don't really know Illustrator or Inkscape, so I just do things in KiCad. Or sorry, in Fusion, and then I just export the DXF into KiCad. And then with all these little holes, you have to like, you can't use the edge cuts layer in KiCad for like small holes because all the I think all holes under like 6 millimeters are drilled rather than milled. So you actually have to make a hole for each of these little tiny holes. So that takes a lot of work, but yeah. Cool. So yeah, it's 2 viewers, but yeah, let's get started on Gondo's BCB. So I'm gonna get back to this later. So Let's start by downloading. Actually, I think I have his latest. Okay, yeah, he hasn't updated his files in over 2 months. So I think I have the latest Acron or the latest KiCad files. Let's see. My GitHub, Anticheww, KiCad files. These are from August 3rd. Yeah, okay, so yeah, I have the latest files. Okay, so we're gonna open this in KiCad and then just export a step file. So, sorry, MetroGain said don't need to know it, it's just lines. Okay. Yeah, I might try it out. I mean, the Fusion workflow has worked pretty well for me so far. So this is Gondo's PCB in KiCad. So let's export a step of this. So we're gonna go to File, Export Step. Actually, let's go to 3D Viewer first and see if all the components I need are there. Because a lot of times the USB port isn't there. So let's see. Okay, 3D Viewer. Yeah, it's missing the USB port. Let's see if I can add that back in. Otherwise, I can just pull the step file off the library and then add it in Fusion. So, so you go to the component. So this is the USB-C port. Right-click Properties. Wait. Update footprint. Open footprint editor. There's usually a properties. Okay. There should be somewhere where it sets the 3D file. Oh, 3D settings. Okay. That is right. Step file. Okay, what makes MetroGain says, what makes the process a lot faster in case you only want to align it? Just export SVG with visual files. Export into Fusion and manually place a USB port. Yeah, I'm probably going to do that because I'm not great with doing 3D stuff in KiCad. So yeah, let's just export it and then I'll just add the USB port separately. Because it has these two like mounting holes and that's a really easy joint in Fusion. So export step. Let's pick a directory. Export. I think I might have exported this already in the past, but let's that way. Meanwhile, let's fire up Fusion. So let's start a project. Okay, yeah. So Fusion puts my real name in the upper left, so that's why my camera's there because I don't want to dox myself through Fusion. Export to FreeCAD after today, right? We'll see. I haven't really used FreeCAD. I should probably give it a try. I've tried like Atom 3D and a couple other like inexpensive 3D softwares. Wasn't a huge fan, so I've kind of gone back to Fusion. I'm really tempted to actually just blow 300 and buy a year-long license of Fusion. Especially because I'm also doing some commission work through it, and I could probably make that back through doing keyboard designs and stuff. It's also just nice to have a like paid Fusion on hand, just so if I make keyboards or whatever. Or if I want to make a new keyboard or whatever. Yeah, I guess I'll probably take a look at FreeCAD. I'm really used to SolidWorks, which is like $4,000, and that's what I generally have used them during the day job as an engineer. So like, I would really like to have that, but that's $4,000 and kind of hard to justify. Fusion does most of what I need to do. Yeah, I'll go check out FreeCAD at some point. I've paid Fusion for another 6 days, and then maybe after that I'll check out FreeCAD. Okay, let's close this because I'm not working on these anymore. So let's start a new project. This is Anticheww case. All right, so let's upload the steps. All right. Yes, I have SolidWorks too. They did a free license last year. Oh, there's a free way to get SolidWorks? Huh. I would like to know that if possible, because I've only had SolidWorks access when I worked at a place that used SolidWorks, and it would be great. Okay, so where did I export that step? Should be an Anticheww step. So the first thing we're gonna do is add the USB port because that's missing. Let's also upload the USB port. So that should be in the Acron library. So GitHub, Acron library, 3D models. Let's do it. The USB Type C 31M12. So that should be the USB port. Cool. Wait for that, and then once we get the PCB set up, I'll kind of describe what I kind of want to do for a case. So let's open the PCB. Should also probably let me rename this to the Anticheww PCB. Okay, so here's the PCB. It's missing the USB-C port, which is, where is it? Wait. Okay, this is the top. So the USB-C port goes here. I believe it goes on the top side. Yeah, this doesn't have parts on both sides, so it should go on the top side. So insert into current design. Let's do there for now. Let's do a joint between these holes and this mounting. I think these mounting pegs. I think I want to do right here. That is not correct. Let's flip it. No. Oh shit. Other thing to do with a PCB. So there's nothing constraining all these like parts on the PCB itself. So I need to do a rigid group so that when the PCB moves, that all these little resistors and stuff move with it. So move components. So let's move this out of the way for now. And we're just gonna select all of this and do a rigid group. So assemble rigid group. Yeah, that's what, like 200 parts. Okay, and then let's join this USB-C port. So this peg should go, I think, to this hole. So should be a very straightforward joint. Whoops. Accidentally press the Windows key to here. That's backwards. No, that's not the right angle. And there we go. Okay, so that should have the USB port in the right spot. Okay, save that. So I guess, yeah, there's only one viewer, but yeah, let's describe what I want out of this case. So let's make the camera a bit bigger. Also, I apologize that this camera is like a potato quality. This is some 480p camera I found in like an e-waste pile like 2 years ago. So let's talk about cases. So I want to do an aluminum case, and I want to do a 3D printed case. So I mean, there's a lot of aluminum 65% out there. I guess it would be nice to show people how to do an aluminum case, because I think that's what a lot of new designers want to do. But I'm personally more interested in doing a 3D printed case, just because, I mean, this is an open source PCB, and I want to open source a case too. And then, I mean, 3D printers are a lot more accessible to people than CNC. So I'm also going to do a 3D printed case. So I'm going to do it similar to the Boston cases I have now. So where's my bus? Oh, here it is. So this is my Boston prototype. I'm going to do a case that's probably similar to this. So the thing with Boston, so I designed this to be made on a 3-axis CNC. So if you look at the side, it doesn't really have an angle. I'm not sure if I can show that well. Okay, there we go. Yeah, sorry, this is a terrible camera. So most keyboards, they look like, I don't know, let's pull up an example. I don't know, let's pick any keyboard. Let's say Austin. So these have an angle on the side. There's no good side profiles. Maybe this one. Let's see if there's a side view. Maybe not. Okay, let's just go to I know what's a random 65%. Okay, Aurora input series. This is kind of a bad example. We can kind of see, like, so you have this typing angle here, and then you have the where it meets the table, and usually this is like, I don't know, 6 or 7 degrees. So a lot of cases have those two as one piece. The issue with that is that's really hard to make on a typical CNC. So typical CNC only has 3 axes, so it can go in X, Y, and Z. If you want to make this angle, it gets a lot harder. You have to either make you have to have special fixturing so it can hold the case at an angle when it mills it. But yeah, so if you have a 5-axis, you can do it pretty easily. If you have a 3-axis, yeah, you need to make special fixturing. 5-axis CNCs aren't really accessible to a lot of people. You're definitely gonna have to send it out to some machine shop. Whereas a 3-axis, there's a chance your local makerspace has a 3-axis. So I'm gonna design this to be easily made on a 3-axis. So I'm gonna do the same thing on Boston, where you have all these parts that are just kind of like plates. It's almost like a sandwich case, but like a lot thicker and CNC'd. So you can kind of see how the top is parallel with the bottom. And then what sets the angle on Boston is there's this third piece here that kind of tilts the whole assembly, and that sets the 6.5 degree typing angle. So I'm going to do something similar where for each part, the top and the bottom are going to be parallel, so that you can easily machine it on a 3-axis CNC. So I'm probably going to do the metal case first, and then for the 3D printed case, I'm going to do something similar to the 3D printed version of Boston, where it's 2 halves. Let me see if I can pull up an example. Okay, I have these 2 case halves for Boston, and then I have this plate assembly that's not really done. So so Boston has this. The way Boston's done on the 3D printed version is you have this FR4 plate, and then I can't really show it that well on this camera. I mean, this is a pretty shitty camera, so I'm sorry. Yeah, it's kind of zoomed in a lot. So you have this case half, and then this is the right half. Then the plate actually kind of slides. It kind of slides in, but it's not. It's not really held on the bottom. Just kind of clips in like this, and then you have this other half that also slides on. And the trick with Boston is there's soldered nuts on the FR4 PCB, and then you can just put a bunch of screws through on the top, and that holds the plate to the case. So I'm gonna do something similar to that on the Anticheww. But tonight, I guess we'll probably start with the aluminum case, because it's a lot more straightforward, and that's probably what people want to see. So let me just check some things. So still down to 1 viewer. Huh. Okay. So first thing to do, so we have the PCB and the USB port. Excuse me. Wait, this is... Okay, sorry, this is up. So all the components are on the bottom. So the first thing let's do is let's start making a plate. That's kind of where I like to start things off. So how I usually do plates... also, sorry, I think where's the chat? Sorry, I think my chat disappeared. Okay, let's just do this. Okay, sorry. So I need to make the camera smaller. Okay, so okay, that looks good. Okay, so let's start sorry, this is not the right thing. Okay, so the PCB. So let's make a plate. I'm probably gonna use swills instead of A03s, just because swills has the little notches on the side that does you can use to remove the switch top. That's not an option on. I don't think that's an option on AIO3's plate generator. So let's go to swills plate builder. So to do this, so to make a plate with this plate generator, we need a keyboard layout editor output. So I'm gonna see if Gondo has a 65%. Yeah. Okay. Here's the JSON file. Okay. Error not found. Nice. Okay. I'm gonna have to make this layout so I can put that into the plate generator. Okay, that's unfortunate. Well, actually, there's documentation here. I got forward. Might be on atronproject.com. So I just need a keyboard layout editor file so that I can actually make this plate. So Metron, Library, Anubis, Shark, Austin, Doodle 60, Elevate. Okay, I don't think Anticheww's on here. Okay. Looks like I'm gonna have to manually make the keyboard layout editor thing. So let's start presets. I think let's start with the 60%. Let's start with a 104 and just start deleting keys. Okay. Let me move this where it's kind of more visible. Maybe zoom in a bit. Okay, so maybe don't want the camera blocking it. Okay. This is a keyboard layout editor. If you've never used it, it's a great tool for just trying out different layouts. A lot of plate generators take inputs from it. You can also try, I think some people use it for key sets, but it doesn't look great for key sets. So yeah, let's make Gondo's 65% layout in this. So first, we're gonna delete the F row because 65s don't have that. Delete the numpad. Then these guys get moved. So let's see. So this is the layout we want to do. Let me try to rearrange these windows. Actually, let's put this on the left and then this one on the right. Okay. So we got. So these are smaller. So also, Anticheww supports a lot of layouts, but for now, let's just do the basic 65%. So this very top, or this bottom row right here. So, there's no right side Windows key, and then these all become 1U. So 1, 1, and 1. This gets moved over, and then there's a 1.75U right shift. So this becomes 1.75. Let's move the arrow keys over. And then have page up, page down, home end. So these actually aren't that important which keys end up there, which keys end up where, as long as their unit size is the same. So as long as all the 1U's end up in the right place. And I mean, this doesn't really matter, but let's just do it anyways. Okay, that looks like a 65% to me. And then we'll add ISO and all the bottom row options real soon. So if you go to raw data here, it'll give you all this raw data. This is what the plate generator takes in. So I'm gonna copy paste that into here. I want MX stab type. I mean, no one's really gonna use CoStar probably. So I'm probably just gonna do cherry only. Case type none. I usually leave all these off and then draw my CAD. And I'll spit out a DXF file. So Fusion will take this in. So let's save this. Documents. Let's say Anticheww case. And then let's name this. This is ANSI base template.dxf. Okay. So let's start with the basic plate. So let's make a folder for. Okay, I can't really see the Fusion nav files because I'm trying to hide my name on Fusion. But let's name this plate files. All right, so we're gonna make a template, and I'm gonna use this to just extrude and pull geometry off of later when I make the actual plate. So new component. Sorry, wrong. New design. Save this as template. And see. Okay, so we're gonna create a sketch on top. Insert DXF. Insert DXF file. Sorry, where did I save this? Downloads. Oh no, sorry, documents. Anticheww case. ANSI base template. This is the output of the plate generator. Just so I can do things properly, I'm just going to fix all this. So when you fix something, it just makes it immovable. You don't really need to do this, but this is in case. Oh, whoops, that just disappeared. Okay, let's just do that again. Millimeter, single sketch, XY. Okay, this looks correct. So let's Yeah, Fusion bogs down real hard when there's this many sketch elements, but we're just gonna fix this so it doesn't move. So we're gonna, whoops. So we hit this fixed constraint up here. Okay, yeah, Fusion really slows down. Okay, I don't want to select it. Okay, you know what? This okay. Let's fix it, and then I just unfixed all of it. Okay. Okay, there we go. Okay, so when it turns green, it's fixed. So we're gonna finish sketch, and then we're gonna extrude this. 1.5. So this is just going to be a template. I'm going to make the, for the actual plate, I'm going to actually have to define the dimensions of the edges and where all the mounting holes that are and stuff. So, but let's save this for now. Okay, Anticheww PCB. Okay, so let's start the actual case design. So we're going to make a new design. Let's save it as Anticheww. Aluminum case. Also, this is gonna be top mount. I haven't really done gasket mount or other styles before, so top mount's pretty straightforward. So let's just do a top mount case. So let's insert the PCB. Whoops. Anticheww. Let's insert the PCB into the design. You save it into plate files. Yeah, I generally organize my actual Fusion folders are usually like extremely messy, but I usually have folders for like plates and PCBs and stuff. Actually, the PCB I sometimes don't put in a folder, but yeah, just how I like to organize things. So we have the PCB. So let's figure out how big we want to make things. And just do I want to start with the plate or do I want to start with the top half or the top part of the case? Let's see. Well, let's start with the top half. So we're gonna make a new component. Let's call it the case top. Case top. Okay, so the thing here, so I really don't want to reference off the I don't want to reference any of the geometry off this PCB, because Gondo is gonna make some updates to the PCB, and then when the PCB changes, I'm gonna have to update the PCB, and that's going to break every single reference. And then I have to go back and fix all those, and it gets really messy. But yeah, let's see if I can do it without it. But actually, we'll probably have to reference off the PCB, at least for now. And then, so let's make a sketch. So this is the top part of the case. So let's draw a rectangle. Okay, how big do we want to make this case? So the USB port here. Let's just do like 8 millimeters for now, off the side of each side. SSD. And if it's top mount, actually it needs to be probably taller on the top. And then you can make the sides pretty narrow if you don't have any mounting holes on the side, which you usually shouldn't on top mount because that affects that's pretty bad for your typing feel if you have side mounting holes on top mount. Don't do side mounting holes on top mount. Let's see. Let's probably get away with like 5 millimeters on the sides. Let's do the same there. I'm gonna copy this dimension to D2. Then bottom, let's do, what did I use on Boston? Here, let me see what I did on this keyboard. Where's my ruler? Okay, I can't find my ruler. I think I have my calipers on my desk. Fuck, I might have moved that too. Okay, well I can eyeball this. So this distance from, I mean, the PCB is roughly at the edge of the keycaps, so looks about, say, that's probably like 9 or 10 millimeters on top and bottom. So let's use those. Let's say 9 millimeters, and then we can make it smaller later if it turns out we can make it smaller. So let's do 9 millimeters, and then 9mm. So what I'm gonna do, I don't want to reference the PCB itself because I'm gonna have to replace that later when Gondo updates the PCB. As far as I know, he's adding a JST header and he might add a center USB port. But for now, let's. So I'm gonna delete all these dimensions, and then but Fusion's gonna leave things the same size when I delete the dimensions, and then I'm gonna delete it in a way that, or then I'm gonna dimension it in a way that does not reference the PCB. So it's 313 by 112. Okay. As long as things don't move, this should be okay. Well, things are gonna move. How do I want to do this? I could just do that off one side here. So I'm gonna have to update these when I update the PCB. Whenever Gondo makes those fixes or makes those changes. Okay, so come to think of it, I should have done this on an offset plane. Fuck. Because when I do this extrude, it's gonna all these features are gonna get in the way. Okay, let me just redo this. Okay, so I'm gonna delete that sketch, and then I'm just gonna make an offset plane. It just makes life a lot easier. Let's set at the height of the plate. So the bottom of the plate is usually actually let's do top of the plate. So the top of the plate, pretty much if you're using Cherry MX in pretty much all cases, the top of the plate is 5mm from the top of the PCB. This is in the Cherry data sheets. It's like the go-to dimension. So we're gonna make this 5mm off the top, and then this is the plane where the plate lays. So then let's do the same thing we just did, where we set the edges of the case. So I don't remember the dimensions. Oh, sorry. I think it was like 6 on the sides. No, there was like 5 on the sides and then 9 on top and bottom. So let's just do that again real quick. Then let's delete these, and then actually I want to keep that. Let's keep those two, and then define this by the size. That way, when the PCB changes later, we only have to update these 2 dimensions and not all of these other ones. So, and then let's pick up distance from the plate to the top. So, how do I explain this? Let me make the camera bigger. Sorry, where's OBS? This is OBS. Okay, let's make the camera bigger. So, I don't really have any good examples here, but maybe I should just do it in Paint. Let's do it in Paint. Let's fire up MS Paint. Okay, so let's move this so it's visible. Okay, so you have your plate. So let's say this is your plate. So I'm gonna pick a. So this is a top case usually, and it looks kind of like, I don't know, usually like this or something. So the important distance, or one of the important distances you want to pick, it's mostly like a visual thing. Is this let's do a different color. Is this distance from the top of the case to the plate? Actually, let's zoom out. So this isn't. So on most keyboards, this is around 7 to 8mm. So this basically determines how much of the keycaps you hide. So so you have your switch here, and then you have your keycap, right? So on a lot of sandwich style cases, this distance is 0. So you don't have any of this. I think like the drop all in like a couple. Like most sandwich cases, there's just a plate here. And then you have this visible gap between the plate and the bottom of the keycap. A lot of people don't like that, and on like a CNC case, a lot of people really don't want that. It depends on how much of the bottom of the keycaps you want visible. So on this prototype of Boston, this is an 8mm. This is with ePBT keycaps, which also sit a little higher, but you can kind of see. You can't really see the bottom. Well, you can kind of see. I think that's a shadow. You can kind of see the bottom of the keycaps just barely. It's a little sunken in, whereas on other keyboards it's a bit lower and you can kind of see the bottom of the keycaps. It's just an aesthetics choice. On most keyboards, I think it's about 7. I'll just make it 7 just because it's common. If you want to kind of have your keycaps look kind of sunken in, I would use like 8 or 9. And then if you kind of want to have it more visible for some reason, you could use like 6. Excuse me. All right, sorry about that. Okay, so let's do 7 for that. So, so we have this case here. Whoops. Oh, okay, sorry, that's okay. I don't have these planes set in a good orientation. So the top of the keyboard was actually the front. Okay, so this is the other really painful thing to do. I don't think I can do this without referencing the PCB. So we're gonna define the edges of the inside edges of the case. So that's usually based off of where based off of where the switches are, and then how much of a gap you want between. Like kind of looking down at the keyboard from the top, where you want how much of a gap you want between your keycaps and the case. So where is it? Okay, so there's a couple important keys here. So this, I'm pretty sure, yeah, this is escape and or tilde. Shoot, it's not letting me project. Oh shoot, what the fuck is going on? Should be in design. What? Okay. Let's have this sketch here. So let's define the insides of the case, or sorry, the inside edges. So let's project a couple of these. So on 65% is a lot easier because there's no key separation. So we're just gonna do these 4 switches on the corners. So, yeah. So escape, control. Actually, control's not a great one to do, but it is what's there. And then I think this is right arrow. So let's project off those so we can get the centers off them. All right, so that's next. Let's make the inside of the let's make the inside edges of the case. Whoops. It's not where we want it. Let's just arbitrarily do it like here. So for this distance, I usually use 10 millimeters from the center of the switch to the edge of the inside of the case. So a typical keycap, so like, I don't know, like a typical keycap is about, well, actually, so the key spacing is about 19.05 millimeters from key to key. And then you want a little bit of room on the edges just so like your keycap doesn't get like jammed on the side of the case. So I usually use 10. It's worked pretty well for me. I think that's what most people use. So we're just gonna set both of these to 10. And that's gonna define the inside corners. So, whoops, 10, and this to 10. And that should define everything. And and then just because we're gonna update the PCB file later, I want to minimize the number of references to the PCB itself. So I'm still gonna redefine these as the dimensions of the length and the width of the insides. Okay, so now that's done. So let's do an extrude. E for extrude. Yeah, we're gonna do 7 millimeters. Okay, so that looks pretty good to me. And then, so that's the top half of the top of the case. And then let's kind of do, we probably shouldn't, I mean, where you want between like the top and the middle, where they, top of the bottom or the top or the middle, where they meet. I mean, it kind of varies from design to design, but let's do it past the bottom of the PCB. So we're gonna do a second extrude, or else to do a second extrude, we need to do a second sketch. So let's do the bottom half of the top of the case, which is, yeah, I guess kind of confusing terminology. So this is also where we kind of set the dimensions of the plate. Let me figure out how I want to do this. So it's gonna be top mount. Let's use an M3. So let's do M3s for the mounting screws. It's a generally pretty safe screw size to use. M2 and M2.5. You kind of have if you're doing an aluminum case, you kind of have a risk of those threads tend to strip out easily. I personally tend to stick to M3 and above. So M3. So let's look up some dimensions of some M3 screws so I can see what sizes to use. That's okay, well, I guess I'm gonna get partly doxed there. Okay. Screws. Socket head screws metric M3. We're just gonna let's just do a typical socket screw. So what's the diameter? So it's 5.5 millimeters by 3 millimeters high. Okay, so let's use that. I just locked myself there, so I'm gonna have to delete the. Let's see if I can like delete those from the VOD and I'll be uploaded to YouTube or something. But yeah, okay, let's make these like 6.2 or so. And let's want to figure out how many screws we want. Let's just do 3 on top and 3 on bottom. That's probably pretty safe. So let's just do one at the corner here for for mounting hole. So here's the case for Boston. So this is a disassembled Boston. This was actually the first prototype. I took it apart because I actually had to steal the switches from these to build another prototype because I'm kind of short on switches right now and I just wanted to build the latest prototype. So I took this one apart. So this is the top case. You can kind of see how do I show this well on the stream? Yeah, this is blowing. Actually, yeah. Maybe actually, let me just pull up the CAD files. That's gonna be easier than using this shitty ass camera. So, where did I keep my Boston files? It's keyboard. So, okay, so this is Boston, or this is the aluminum version of Boston as I have it right now. So, the top case, let's isolate it. So I kind of did it this way where, where's the plate? Here's the plate. Wait, that's not visible. Okay, here's the plate. Okay. So on top mount, you have the plate, and then you kind of have this protrusion off the side with a hole in it. So that's where the plate mounts. And it mounts the top side of the case, hence top mount. So I have these little dimples here, are kind of like these like circular cutouts in the case for the screws go. Oh, and then I have this for attaching the bottom. But let's add those features. So, so on this sketch, we're gonna define where these circles are, and also I have these opposing circles. That's where the middle of the case mounts. So, oops, not visual. Let's do visible edges. So that's where the case screws that mount the middle of the case to the top of the case go. So let's do something similar. Okay, so this corner we probably want to use as for the case, and then let's do 3 on 3. Let's do 3 screws on top and 3 screws on bottom. Maybe 2. I mean, so, this is the USB port there. That's good. Makes things a little trickier. Oh, that's really recessed. Okay. Another consideration is this USB port and where I want to put. Let me think. Okay, so let's have these corners. So we'll have screws that mount the bottom or the middle of the case to the top, going through these holes. So let's do like 4 by 4, and then where's some logical places to put mounting holes for the plate? So we have the middle, I guess. Let's make a construction line here. Let's make this circle coincident. And then let's do another circle in the middle. So wherever the midpoint right here is. And do one opposite at 2. Is that a construction line? And I'm gonna do the same thing on this side, but same as that, but just on the other side. Actually, I could just do a mirror. That'll be easier. So what do I want the mounting? Holes for the plate here. Oops, let's do this. So let's add more holes to the bottom. Create mirror. This circle and this circle to the bottom. Then we're going to mirror these 2 circles across this middle line here. Okay, so let's use these for mounting the case, and then we need to pick separate locations for the plate. This USB port location is unfortunately kind of annoying. I'm pretty sure Anticheww was designed for was it not gasket mount, the for tray mount, so it doesn't really have to worry about this. But since I'm doing a top mount case for this PCB, I'm going to have to. This USB port is unfortunately placed. Let's see. Could just do like here. Like let's do. Actually, for the tops, let's do for the screws that mount the top of the case to the middle or the bottom. Let's do let's do 4 of them, and we're just gonna divide this length into quarters. So this is what oops, sorry. So this circle and this circle are 305.241. So let's fire up the calculator. Let's divide that into 4 of them, then we need 5 gaps. So just call it 61. Okay. So is that right? It doesn't look right. Oh no, there's 4 gaps, not 5. Okay. Sometimes I don't know when to add 1 and when to not add 1. Divided by 4, 76.3. Let's just call it 76. Okay, that looks better. So that'll be for the. That still doesn't look right. Oh, actually, it's 3, not 4. Okay. So what was that distance again? Was it 305.24 divided by 3? So 101. Okay. That looks a lot better. So do the same thing here. Equals, and then symmetric. 1, 2, and 3. So we'll use these 4 for mounting the top to the bottom, and then for mounting the plate itself, we'll use this middle one, and then let's add one to each end. So I'm gonna be observing this USB port. Actually, I could make this asymmetrical, so this is home row, so you're mostly gonna be typing here. So you kind of want to feel balanced on the alpha keys, and then these are just like nav keys, and if your feels a little more inconsistent there, I don't think that's much of an issue. So let's do what, like 15. Let's do like 10. Let's do like 10. Okay. Now let's mirror that. We don't need. Actually, we don't want to mirror that because of the USB port. That still might end up feeling inconsistent. Because I really want to put the mounting point for the plate like right above this key here, but that's gonna get in the way of that might not get in the way of the USB port. Let's do like here, whatever this is. Let's do like 8, and then I don't think that's gonna interfere with the USB. Because I mean, you have the USB cable coming in, and then that's kind of wider than the port. Actually, let's do some measurements here. Where are my calipers? Oh, there's 3 viewers on the stream. Hi everyone. I'm designing a case for Gondo's PCB. I'm kind of in the middle here, so I'm just designing the top case right now. For those new on the stream, I'm designing the top half of the case right now. Just choosing the mounting points for the plate. This is a top mount plate, or this is a top mount. This is going to be a top mount case, so I need to choose these wisely. I'm trying to choose this hole so it doesn't interfere with the USB port. But to do that, I need to know how wide a USB connector is. To do that, I need to measure a USB connector. To do that, I need to find my ruler or calipers. Actually, let me just go look right now. I'm going to temporarily... I'll be back in like a minute. I'm just going to go look for my calipers. Yeah, sorry, I'll be back in like 2 minutes. I'm going to go look for my calipers. Hello, Foggy Flute. I think, are you Foggy on Discord on the keyboard outlier? Oh, found my calipers. So, okay, there we go. Sorry. Yeah, okay, awesome. Yeah, we're some of the more active people on that Discord. So, I want to place this where it doesn't interfere with. If I'm gonna plug in a USB cable into this port, I don't want this to interfere with it. So I'm just gonna go measure some USB-C cables right now. So I have this cable for my keyboard right now. This is what? This is 12. Let's use 14. I think that's what I used on Boston also. So off the center of this port, let's put a point in the middle of this USB-C port, and then. Okay, how far is this right now? 10. Okay, yeah, we can't put a hole here. Why is it 6.2? So a typical M3 head, an M3 socket head, is usually about 5.5, and then you just want a little bit of wiggle room. Actually, I might make these bigger. Actually, make these 6.4. If I make them 6.4, I can use. For all you Americans who use the Imperial system, if you make it larger than 6.35, you can machine this with a 1/4-inch end mill, and your machinist will thank you if you can machine it with a 1/4-inch end mill. I mean, if you're getting it made in China or whatever, you can just use this. It only needs to be larger than 6, so you can use a 6mm end mill. That's a pretty common end mill size. Personally, that's like the smallest end mill that I just am not really afraid of breaking. Once you go smaller than like maybe 4mm, your end mills start getting really fragile, and they start like snapping really easily. And I don't enjoy machining with small end mills just because you have to be real gentle with them or they start breaking. So where do I want to put this hole? We could just do it like right over, where's it? Backspace, I think. This is probably backspace. Sorry, let's pull out the layout. Okay, so this is page up, and this is split backspace. Yeah, so most people use M2. So Foggy really hates M2. I personally not like. I've mostly used M3 these days. Just for like all sorts of. in my engineering work and just pretty much everywhere, I've never really gone smaller than M3. I think I've done like a thing or two with M2, but like M3 is like a lot stronger than M2, and it's a lot more resistant to stripping. Also, the larger your screw, the larger like the head of the screw is larger, and like the hex they use for the Allen key is larger, and like the larger your like hex head is, the harder it is to strip. Like M2s use really small Allen keys, and it's really easy to strip the screws. Like it's really to strip both the threads and the head. So yeah, I would like to stick to M3 on this design. So let's try to put this over like here over. Wait, so wait, this is backwards. Is this caps lock? No, it says a right side USB, right? Wait. Shit, this might be okay. Oh, okay. Actually, this is upside down. Wait. Okay, so I'm just getting confused over the orientation of the PCB. So this actually looks like the left side of the PCB, and this looks like the right. So these are arrows. These are the nav keys. Then this would be backspace, which would make sense because the stab holes are here. Oh no, this is okay. I'm just getting real mixed up over the orientation of this PCB. So this is bottom row. This is the left side of the keyboard. So actually, okay, it's fuck. Okay, everything's upside down then. Fuck. Okay. Foggy flute. Foggy says usually I use a 4mm mil bit, then a 2mm mil bit. It's not fragile. Anything less than 1.5. Oh, radius. Okay, I thought these were diameters. It is kind of more fragile, mostly due to keyboard case. Yeah, that makes sense. So you're using an 8mm diameter and then a 4mm. Okay. So this case is actually upside down, which is unfortunate. So fortunately, let's just go back and edit these features. So you can use 6mm hole fine, save you some wall thickness. Okay. I mean, if someone wants to get it made in the US, I should probably do like 6.4 in case. Because the US machine shops generally use imperial tooling. So instead of 6mm, it would be a 1/4 inch. So that they can use their larger end mills. Metro Gang says rotate it 180 around the center axis of the PCB. Yeah, but it's more proper if I go back and edit the features. I'm a huge proponent of like parametric modeling in general, where you kind of do everything as features, and then if you want to fix something, you go to the earlier feature and you fix the thing. So this top half, yeah. So this is upside down. So this plane is off the wrong side. So we're gonna redefine this plane to the top side of the PCB, and then 5mm off that. Okay, so we're gonna redefine the sketch plane. So yeah, the thing when you go back and edit features, it breaks later features, so you had to like go back and fix everything. So we just edited this plane, then we had to edit the sketch. So this is a hot mess. But we're gonna fix this. So this is 9mm. This is backwards. Okay, yeah. We're just gonna redimension this whole thing. That looks right. That looks right. That looks right. So this thing. Let's drag that here. This is 10mm from the bottom. And this is 10mm on the side. Yep. Then this edge. This is 10mm from the top keys. Should did that. Oh fuck, fusion. Okay. This just added a relation that I didn't want. Wait, what just happened here? Oh, okay. Oh, fuck this. Okay. This shouldn't be on this, but I can't find the relation that's causing it to do that. Yeah, I'll just delete it and remake it. Okay. This is the inside. This is the outside. This is the outside. Okay. It's 10mm. Then we need to delete this here, delete that one so it doesn't reference the PCB. And this sketch here. This is a hot mess. Okay. But it's going to be fixable. We're going to make it out of this. Horizontal, and then 9 millimeters from here. 9 millimeters from here. And the sides were 5, I think. This is D38. Okay, cool. This is gonna break. Oh, okay. Oh, the extrude fixed itself. Okay. So I think we're on the right side now. So this is. I'm pretty sure this is caps lock. So this is centered, stepped. This is control. This appears to be a shift key based off the steps. This appears to be arrows. Okay, so I think we're oriented right now. So now we're gonna fix this sketch. I'm just gonna start the sketch over again. This is okay. So we're gonna look at the bottom side of the top, and we're gonna choose mounting holes for the plate because this is a top mount case. So what was I doing? So let's make some circles. Let's make a 6.4 for the reasons I said earlier. Okay, so Foggy said you should really center everything to the origin of the file. I even fixed my assembly center to origin. Makes it important to render. Yeah, so I did it in SolidWorks. Fusion, I don't even really know where the origin is. This is all kind of floating right now. I'm just joining everything to each other. Where is the origin? Okay, the origin is here on the. I believe that's an escape tilde key. Okay. Oh, that's because that's just the origin on the PCB. Because Gondo's PCBs all have their origins on the escape key. It's gonna be a huge pain to move it right now, so I'll just. Yeah, but normally you should for parametric modeling. Normally you should locate your planes and your origin in the center of the part. It makes a lot of things easier. Like if you need to mirror parts or join things, it makes it a lot easier if your origins and planes are in the middle. But that's not the case here, and we're just gonna live with that because I really don't want to move this to whatever. There's gonna be a million decimal points, and it's just gonna be a huge pain. That might save me some trouble later. But I mean, if I just want planes, I can always just add additional planes to the center of this part. So it's not a ton of extra work if I don't locate the origin optimally. Okay. So let's do 6.4. I should actually make the top and the bottom taller. Because, yeah, this is going to leave you with, a very small wall thickness. 0.8. Yeah, that's a really thin wall. Let's make the top and bottom a little. Actually, I could just make these not 4. I can make them 5. Yeah, I think that should work. Okay, so what are we doing? So we're going to do that. Make a bunch more of these circles. That will define where the holes for the plate will be. Actually, let's just do a bunch of mirrors. So we're gonna make some sketch lines to mirror things. Why is it not picking up on this? Okay. Center, midpoint to midpoint. Let's make another one across the other axes. So middle to middle. Make that construction. Just see who's viewing the chat. Okay. So probably be a bit less work. So we're just gonna do a bunch of mirrors. So let's mirror this across this line. Oops, wrong line. And then let's mirror these two across this line. Okay, so that's 4. We'll probably use these for the case rather than the plate, but it's still good to have in the. Excuse me. It's still good to have that in that sketch. Then let's make 2 more in the middle. Make them equal to 6.4, and then we'll make them horizontal. Okay. So have those, and then we want. So we'll use this. We're adding more holes for the case. Actually, let's do So what's this distance? So if we want 4 holes across the top, there's 3 distances between the holes. So I'm gonna measure this total distance from these. So that's 303 for 1 divided by 3. So 101. Okay, so maybe 101 apart. Make you equal and horizontal to this one. Okay, and then I'm gonna mirror that a couple times. So same thing. Actually, let's save the mirror for a little later. Actually, no, let's just mirror now. Mirror this. Mirror those two. Then, so we'll use these 4 for the case, for attaching the top side of the case to the bottom. And then we need to choose another 4 holes for attaching the top mount plate. So this one, let's do here. Then horizontal. Just like located like right above the escape key. I'm trying to minimize references to the PCB because again, I'm gonna update. When Gondo updates the PCB, I'm gonna have to update this step file, and that's gonna break all the references. So I'm gonna have to go back and change all of them when that happens. And so to minimize that work in the future, I'm just gonna try to avoid referencing the PCB, but we can temporarily reference it. Just to move the features, and then you can just delete this reference and then dimension off of some other feature. So this hole will be right above, 10 millimeters. Oh, that's clean. Okay. So we'll do that here. That's not gonna work on this side. So could do it right above the, is this upside? No, it's not upside down. That's escape. So, oh, this is 1. Okay, let's just do it right above the, let me think. Okay, so we also want to make sure this doesn't interfere with the USB port. So we're gonna do 14 millimeters wide for the opening for the USB port. So okay. So 14 divided by 2 is 7. Then we want to make sure there's enough, like thick enough wall between. So there's gonna be an opening for the USB port here, and then there's gonna be this mounting hole for the plate. Just like 5. So like this is kind of not ideal because well, I really want this like here. So the corner is supported rather than like kind of offset a bit, but it might be okay. I mean, I can't really put a hole here because that interferes with the. I really want the mounting hole screws. I really want the screws that attach top to the bottom, beyond the corners, like both for aesthetics and for like all sorts of other reasons. So I can't really mount the plate here. I can't really do it here because yeah, that'll interfere with the USB. So we'll just do it here. Okay. Let's make this equal. Then horizontal. Okay. What else do we have? Okay, so I need to mirror that. Actually, just to make things. Actually, no. Actually, yeah. Let's just do this. To make things consistent, we'll just mirror this one across to the other side. So we'll mirror this hole to the other side. And then we'll mirror both of these to the bottom of the case. Cool. So then let's add this rectangle. So then we're gonna do another extrude above this to. So you'll have, so right now this face of the top of what I have right now is gonna be where the plate is, but we want a lot more material past that to form the sides and the tops of the case. So this one, Okay, this interferes with the PCB here. Okay, this PCB is not, is this centered? Okay, so this PCB is technically off center, relative to where the keys are. Actually, is it? Okay, okay, that's bad. That's not where that's supposed to be. That's correct. Okay, so the dimensions. So this earlier this earlier sketch, the dimensions are not correct. This one, this should be past here. So let's change that. What's defining? Oh, okay. Cool. That looks correct. That looks correct. The PCB is still appears to be asymmetrical relative to where the keys are, because you notice where this gap is larger than this gap. But it is correct off where the centers of the switches are. So we'll just keep that as is. And then I'm trying to minimize references to the PCB, so I'm gonna redefine these. Cool. All right. So then, how did that affect the sketch? Oh, it actually bought me more room here. That actually might let me move this hole from this side to here. Let's see if I have space for that. This is the edge of the USB cutout. Okay, yeah. I think I actually have room to do this. Okay, cool. That's a lot better. So this looks like a reasonable wall thickness. 6.5. So how thick is this wall? 4.5. What's the minimum? 1.3. Yeah, that's pretty good. Okay. So this is why you do relations. So when I updated this, it moved all the other three automatically, which is great. That's why I should use mirrors and relations, because it just means things update by themselves and you don't have to go in and edit dimensions later. Okay, so we're done with that sketch. So now we're gonna do extrude to make the kind of the walls on the sides. So we want this corner. We don't want this. We want this. We don't want that. So the ones where like I'm choosing the additional like extrude stuff, that's gonna be where the screws that mount the bottom of the case to the top are gonna be. So we want that, and we want these. These. We want these. These, and we want these. So how tall do we want to make them? Let's just do 10 for now. And then we might want to go back to this. Okay, so how thick is the case right now? You also want to, I'll just fill out those later. So you want to choose the thicknesses of parts based on available material stock. So this is 17 millimeters. So let's bring this down to 15 because that's a really common material size. So you want to choose thicknesses based off of like how thick sheets you can get material in. I think I'm not familiar with the metric ones, but like in the US you can get like 1/4 inch. The next size up is like 5/16. Next size up is like 3/8 or whatever. You want to choose a size that's a common size and then make that as fairly close to the thickness of what you can get, but not exactly because you want a little bit of room to remove material. But if you make the thicknesses like relatively close to the stock size, then that minimizes them. That reduces the amount of material that the machinist has to remove when they're making the case. You might end up in like what you really want to avoid is like, same material comes in like you can get 20 millimeter thick and 25 millimeter thick, and there's nothing in between. If you make like a 20.5 millimeter thick case, what's gonna happen is the machinist is gonna have to buy 25 millimeter thick stock and then shave off 4.5 millimeters to get the thickness you want. Whereas if you had made that case 19.5 millimeters thick, then they can buy 20 millimeter stock and only shave off 0.5 millimeter off each side, or 0.5 millimeter off one side. So it just reduces the amount of material that has to be removed, and that just makes everything a lot cheaper. When you buy thinner stock, it's cheaper. So you want to choose your thicknesses carefully. So 17, I think the only available size above this is 20. and I don't want like the machinist to take off 3 millimeters. So let's make this like 14 and a half thick. Also, I mean, there's also aesthetic considerations and stuff, but this is just going to be some open source aluminum case. But let's just do like 14 and a half for now. So we want to cut this extrude by, so this is 17 right now. Just want to reduce it by 2.5. So 10 minus 2.5 is 7.5. Okay, so this should be 14 and a half now. Cool. Though that, oh, we also want to put the thick, we want to be careful where the USB port is, or where how thick this is for the USB port. I'm also going to have to model the cutout for this later. Let's make this a little, wait. I kind of want the seam to kind of be in the middle of the USB port, so you can make the USB port without having to do a dedicated like hole in the side, which adds a machining setup. I can explain that a bit better once I actually model it. So okay, so we have this distance show. Sorry, I was gonna check something. So we do a section analysis. Let's just kind of do like a cutaway view. So where is this seam relative to the USB port? It's pretty close to them. I could make it a little taller. We really want to be about like here. It's got like a millimeter, but that kind of gets close to the 15 millimeter stock size. This is probably fine. Okay, so let's turn off the section view. Okay, so what do we want to do next? Let's add a bunch of fillets now. So for fillets, on the outer case, so on the inside, I usually use 1.5. Actually, I use 1.6. That way you can use a 3 millimeter end mill. 3 millimeter end mill to make these corners, and that's a pretty good size to do it with. And then that also, 1.6 is about the largest you can go without really. You can probably go a little larger, but the larger you make this fillet, I mean, you can use a larger end mill to mill it, which is nice for the machinist. It makes things a little cheaper, but sooner or later, this fillet is going to start interfering with the corner of your keycap. So I think 1.6 is generally a good size. You can go smaller, but it'll kind of cost you more because the machinist has to use a smaller end mill. And small end mills, they break more. They don't cut as fast. They break more. There's like a maximum depth they can go. Generally, larger end mills are better. Up to about, I say, probably 3 millimeter radius, maybe 4 millimeter. Past that, you don't really get as much out of it. So we're gonna add those inside fillets, and then for the outside, this is really just an aesthetic choice. So outside corners don't even need a fillet, but you don't really want the sharp corner because this is gonna be a really sharp corner if you machine it this way, and then you're just gonna like hit your palm against it and draw a lot of blood. So we're gonna round these just to prevent the user from getting cut. Just do 5. Let's see how it looks. It's kind of squared off as far as cases go. Yeah, how does this look aesthetically? Part of me wants to make the walls thinner. Oh, hey Gondo. Okay, PCB. Let's see, PCB check. Pylon check, components check, case check, Fusion. Yes, I am in Fusion. There was news earlier today that Fusion's making their free version like a lot worse. So they have like a free version for personal use, and it's used to be like the exact same features as the paid version, but it's a lot worse. Or they're gonna make it a lot worse starting in October. So there's a lot of talk about people moving off Fusion. Gondo also prophesied that Fusion would get Autodesk is gonna make Fusion like a lot worse for free users in the future, and he was correct. Fusion used to be like basically free even for commercial use, as long as your company made like less than $100,000, which is like a lot of money. Okay, you didn't prophesize anything. Okay, but you were correct. What you predicted has turned out to be true. But I'm doing this. The same thing happened with Eagle, MATLAB, and SolidWorks. Okay, I was there for Eagle. Like I switched from Eagle to KiCad when Autodesk bought Eagle, and I mean, Autodesk has a reputation for like they try to get money when they can. MATLAB and SolidWorks, I wasn't really there for that, but I yeah. We're in Fusion because I think most people still use Fusion. I'm gonna try out FreeCAD at some point, but I actually have paid Fusion for I think another 6 days. I think it expires the 22nd. So I'm gonna use Fusion till then, and then I'm gonna think about I can either switch to FreeCAD, OpenSCAD, whatever. I can switch to another CAD software, or I might just like pay for Fusion because there's like cynically they have like a 40% off sale. The same like when they announced that they're gonna make the free version a lot worse, they said they're gonna have a 40% off sale, and that's real tempting. FreeCAD definitely has a learning curve. Yeah, I've heard not great things about it. I've had friends try it and they said like the user UI is terrible, but I guess yeah, as with anything. It's not pretty, that's sure. It will only get worse. Yeah, it's like when you want to jump off the Fusion train, like the sooner I switch to FreeCAD, the less it will hurt later. But yeah, I'm still really used to Fusion. Evil says the newer FreeCAD has an extension called Modern UI, which makes it a bit better. Okay, yeah, I'll check that out. But yeah, we're in Fusion, so so kind of getting back to the design here. I kind of like aesthetically, I kind of want to make this like the thickness of this wall match this wall, but it's not like necessary. It like kind of makes your keyboard a little wider, which some people don't like because they want their mouse space. So like, I can always change that later. So okay, let's just proceed with this. So I have a rough top case. So I was adding fillets. Okay, so I made these 1.6. So okay, sorry. The chat scrolled. Gondo says what happens always is the companies make their products free to make people used to it, and they use the feedback to make it. And then he says when it's decent they log it. Yeah, like this was really predictable with Fusion. So I first used Fusion so I worked for a company that was using SolidWorks, and then a bunch of Autodesk salespeople showed up, and they were like, "We have Fusion 360," and it's like their selling point then was like we had an industrial design team that was on Rhino, and then we had the engineering team on SolidWorks. And Fusion tried to kind of sell themselves as like we can kind of do both direct modeling and parametric. So your engineers and your designers can be using the same software. They kind of sold it as that, and also it was really cheap. It was like way cheaper than SolidWorks. So the company I work for switched to Fusion. And yeah, Gonda says everyone call me a lunatic for using Blender, Inkscape, and Fusion. Okay. I know Blender and Inkscape are open source, but I'm not sure how Fusion fits in there. Everyone gangsta until Fusion not free anymore. Yeah. I mean, it's still free, but it's just getting worse. Like, you can still 3D print things with it on the free version. Since I'm, like, trying to sell keyboards, I'm on the paid version anyways to, like, not violate terms of service. Though I'm not sure how they're catching commercial use on the personal version. But, yeah. Sorry, what was I saying about Fusion? Yeah, my old boss was like... So, at the time, there's another sort of free... CAD software called Onshape that was kind of taking off around like 2016, and then that was free for personal use too, but it was a lot of money for commercial use. And yeah, my boss was like, this is Autodesk's attempt to kill Onshape because they were trying to make Fusion free. They were probably going to try to make Fusion free until Onshape went out of business and then jacked the prices way up. That wasn't what exactly happened, but I mean, they kind of seem pretty successful in getting a lot of people to use it because it's free, and then making the free version worse and trying to get people to pay for it. So yeah, back to this design. So everyone called me a lunatic for using Blender, Inkscape, and FreeCAD. Yeah, I mean Blender and Inkscape are really good these days. I'm not great at Blender. Inkscape I can kind of use, but like they're both pretty great for what they are. FreeCAD I just haven't tried. So we're gonna kind of back to this. We need to fillet these sharp corners because these aren't machinable. I'm gonna see if I can do a 3mm fillet on these so that they can use a 6mm end mill to machine these. Okay, that worked. It just looks a little funny, but that's fine. So let's use 3mm on all of these sharp internal corners. This one, all these corners. I think there's like a rules fillet feature now where you can like automatically have fillets form if like certain conditions are met, but I haven't really looked into that. So I'm just doing all these fillets manually. I think that's all of them. Or all the internal ones. Cool. And then these, you don't really have to touch these external ones for machinability, but these sharp corners hurt a lot if you like your palm lands them on there or something. So we're gonna fillet them just so people don't bleed when they assemble this case. So these, you can pretty much choose any fillet size as long as it's not 0. Even like a 0.5 millimeter fillet makes corners a lot less sharp and a lot less prone to drawing blood. Let's see. I'll probably do like a millimeter fillet on these. Here and here. I think that's all of them. Let's just do a millimeter. Oh, that looks pretty good. Okay, so that's the top case for now. Let's also add some chamfers for now. Let's add a chamfer here and here. Let's just do like a millimeter. Huh. Okay, that actually kind of looks a lot better now. Cool. So that's kind of the initial top plate. We still had to add a bunch of holes for the case and the plate. But do we want to do that now? Yeah, let's do that now. Okay, so let's add a bunch of holes. So we're gonna add the tap holes for the plate. And then we also need to add tap holes to attach to the bottom case. So we use hole tool. Actually, let's hide the PCB for now. Okay, so we're gonna use the hole tool to make these tapped holes, but whoops. I just pressed Windows key by accident. Okay. So let's start with hole tool. So hole tool, the hole tool wants a sketch as the input, so we're gonna make a sketch first. And then we need the centers of all these circular features. Though you can just cheat and just press P and just project all these, and then every time it grabs a circular feature, it'll also grab the center point of it. So grab these, and then I also need the ones for the top. So I'm gonna press P for project, and then select this face, and I'll grab all these edges. So now I have all these centers. So cool. And then next, we're going to use hole tool. So we want a tapped hole. So want a simple hole, but tapped. Excuse me. Sorry about that. Okay. From sketch, so let's choose all these center points. Okay, so this is the hole dimensions. Okay, Foggy says, let them bleed. That makes them know Keeb is serious stuff. You need sacrifice, sweat, and blood for it. Maybe on the designer end, I don't believe in end users having to bleed. I'm pretty sure. Yeah, I've drew blood on designing Boston or making prototypes just from like, I think there was a corner on the plate that was kind of sharp. But yeah, I would like to minimize physical injury when assembling keyboards. So back to this hole. So hole dimensions. So we want a M3 hole. So was ice clearance, thread offset. Okay, we want a M3 hole, so 3 millimeters, and 3 by 0.5, 6H. This is just a fit class. Pretty much everyone uses 6H. M3 by there's different M3 sizes. So M3, there's a fine pitch and there's a thick pitch. 0.5 is the coarse pitch. 0.5 is the most common one. Don't use the other one. Everyone's gonna get mad at you if you do. Right hand, cool. And then you want to select the hole depth. Let's just keep it at 2 for now. I'm definitely gonna make it a lot deeper, but I need to see how deep I can make it. So let's select all these points for tapped holes. Okay, I could probably go like 6. Okay, so we have those holes. Then I'm gonna see if how close the bottom of the hole is to the top, because we don't want the holes to like poke through. So that's gonna look bad. Foggy says, I have another hobby called ballast song, butterfly knife. I don't know what that is, and bleeding got glorified. Huh. I don't know what that is, but interesting. You can kind of see like it's with knives maybe. Yeah, bleeding is can be seen as some like a ritual passage or something. So this is the bottom of the hole. This is kind of close, so we're gonna make this hole less deep. Let's see. How much room do I have? Oops. I get why people have win keyless keyboards now, because when you're not looking at your keyboard, it's really easy to hit the... When you're going for control, it's really easy to hit the Windows key. 0.24. Yeah, that's a little low. Let's make the hole 0.5 millimeter shallower. Feature, let's make it 5. Oh, it's sorry, we're gonna make it 5.5. Okay, so yeah, it looks pretty good. So 5.5. So that means a thread. So that's for the hole, but the threads can't. So when you make a tapped hole, usually you use a tool called a tap, which I don't have one in front of me, but it looks like a screw, but it has a bunch of like cutting features on it, and you run it down this hole. So when you make a threaded hole, the threads can't actually reach all the way to the bottom, because of just the limitations on how tapping is done. Usually you can get 2 threads. The threads can go as deep as like 2 threads above the bottom of the hole. So for M3 by 0.5, the threads are 0.5 millimeter apart. So 2 threads is 1 millimeter. So the deepest the threads can go is 1 millimeter from the bottom of this hole. So that's going to be 5.5 minus 1. So there's going to be 4.5 millimeters of thread. That's pretty good. You usually want at least 1 thread of engagement. And then you just want to make sure that it's also deep enough for whatever screw size you want to use. Foggy says, usually the last millimeter to 1.2 millimeters of the closed hole threads can't be used since the threads tap need to be smaller cut to start tapping. I see. I've usually just heard 2 threads. For M3.5, that should be 1 millimeter. But yeah, it's just the tap can't go all the way to the bottom just from how it's shaped. It's kind of hard to explain over this video. So I have 4.5 millimeters of thread, and there's going to be 1.5 millimeters of plate. So I can use a 6 millimeter screw to attach the plate to this hole. And then usually, like, screws usually come like a hair too short. So this camera is... Screws usually come like a hair too short. So like a 6 millimeter screw is going to be like 5.8 or like 5.5. So I can probably safely use a 6 millimeter screw to attach the plate. So that's that hole. And then we just need the holes for attaching the top of the case to the bottom. So we're going to do the same thing as we did. We're going to make a sketch, project this entire face to grab the centers of these. And then now we have these center points. Let's make some holes. I can probably just keep these. Actually, I can make these deeper because I have a lot more room to play with. So let's select all these center points. Okay, cool. So actually, I need to use the bathroom for like a minute. I'm going to be back real quick. Okay, and I'm back. So we just finished the top side. So let's start with the plate now. So we have enough features to make the plate that fits inside here. So we're gonna make a new component. We're gonna call it the plate. Oh, sorry. This is one of my main gripes with Fusion. So you have to make sure the right thing is checked when you're doing any work, or else your work is gonna go into the wrong component. I personally find it super annoying. I personally prefer how SolidWorks keeps its parts separate from its assemblies, while Fusion tries to kind of make it all one. It just leads to a lot of messy stuff. So we're gonna make a new component called the plate. Standard internal. I'm gonna call it the plate. Okay, so the plate is gonna be on this plane here. So let's make a sketch there. Whoops. Okay, so we're just gonna project the we want this outline, but I'm just gonna do this whole thing. And then we want this, and we want this line. So I'm gonna go back to shaded with visible edges. Okay. Didn't grab. Okay, so I need to grab this entire outline. Oh fuck it, we'll just grab his face. Okay. That didn't work. Okay, I'm gonna manually select all these edge features. I think that should be all of it. Okay, and then we actually don't want these ones. Okay, so this is the outline of this like cavity. That's where the plate's gonna go. So sorry, I don't want this little guy. So we're gonna do a slight offset. So you don't want to make, so you have this like pocket that the plate's supposed to fit into. You don't want to make it exactly that size, because inevitably like the manufacturer is going to make this case a little too small, or the plate is going to be a little too big and it's just not going to fit. So you want a little bit of clearance so that if either of those two are a little off, it's still going to fit. So we're going to make the plate a little smaller than this outline here that it's supposed to fit into. So we're going to do an offset. So we're going to use an offset tool and grab this edge of the sketch, except what's going on here? Okay, actually, so what I actually want to do, there's a minor issue here where, so this wall is kind of one wall right in here. I kind of want to extend this cutout a little bit past here so that the edge of the plate, there's going to be a gap between the case and the plate, and I don't want that really visible. I want that gap to be past. This is probably not a great explanation, but I want to extend like a portion of this wall, like a little bit, like this way. So I'm gonna fix that real quick. In case top. So, oh, it's this. Wait, is this actually the? Okay, yeah, this is the extrude. Okay, so this line needs to. What are the relations on this line? Might be on the other one. So this line. This is the general thing I hate about relations. It's really hard to see what relations things actually have. What the fuck? Oh, okay. It's this dimension. I want to change this to 4. There we go. Okay. Okay, excellent. So now there's a little. You can kind of see this wall is a little offset. I apparently broke this sketch over here. Oh. What is this sketch? Oh, that's for the holes. Okay. So you kind of see this feature is yellow. It's kind of hard to see on the screen, but something's broken on the sketch. Don't know what it is. Actually, you know what? Oh, it's on this face. Sometimes, okay. So when I don't know what's broken, if it's like if it's a feature that's kind of towards the end and there aren't other features that are relying on it, I'm just gonna remake it. So oftentimes that takes less time than just trying to fix it. So we're gonna redo those holes we did earlier, just so the feature tree isn't broken. Because broken feature trees are bad. Do not have red or yellow features in your feature tree. It is just bad. It will cause you a lot of problems later, so do not do it. Fix it when you can. So we're gonna make those holes again. I think it's saved the hole settings. So M3. Let's 8 millimeters deep. Yep, this is correct. Okay, cool. So those holes are gonna be remade. Okay, those holes are done. I have a slight concern. I think there's enough wall thickness between the edge of this hole and this wall. Excuse me. That's a little close. So it's an M3. So you're gonna lose half. So it's gonna be a half a millimeter wall thickness. Should be okay just because it's a hole. It's not like it's not like a large pocket. It's just a hole. So there's only one part that's a little thin. So that should be fine. Not too concerned about that. It's still not great. But okay. Well, let's get to the plate. So this is the plate. This is gonna be the sketch that makes the plate. So I'm delete this. Actually, let's just do this all over again. All right, we're just gonna project this face. Okay, that got us everything we want. And then we're gonna do an offset off this kind of like outline here. So, just curious who's still watching the stream. Okay, 4 viewers. So let's use the offset tool. I usually do like a half a millimeter off the edge. That's probably a bit much, but I mean, in a lot of cases, more clearance doesn't hurt. This is one of them. A lot of clearances, more clearance does hurt, but this is not one of them. So let's do half a millimeter off the edge. Cool. Then, so it gets us the outline, and then we also want holes on the plate to mount them. So these are going to be M3. The clearance size for M3 is 3.4 millimeters because we don't want threads in this plate. So, yeah, 3.4. How much distance do I have between here and here? One's pretty good. Okay. So, one's a little thin, but it'll work. I use one. I use 1 millimeter in Boston, and that worked fine. So we're gonna make a bunch more of these holes. 3, 4. It's a little big. 5, and last one. And then we're gonna spam the equal constraint a bunch of times. So this hole is gonna be the same size as this hole, which is gonna be the same size as this hole, same size as this hole, same size as this hole. Okay, that's all the holes. Okay, and then we're gonna make the plate. So we're gonna do an extrude off the sketch, select all the correct features. Cool. So plates are usually 1.5 millimeters thick, unless you're trying to do like a really thick plate. But 1.5 is the usual. Then your switches clip in really nicely. So we're gonna do 1.5. So that kind of, yeah, so this is gonna be a plate, and then we need to make all the cutouts for the switches. So, earlier on the stream, when there was, I think, just one person watching, I used Swill's plate generator and keyboard layout editor to make a, where did I put it? Anticheww case plate files. Okay, so I made this template using keyboard layout editor and Swill's plate generator. Looks pretty good. I'm gonna have to add a bunch more cutouts so Anticheww supports a lot of bottom row layout options. This one is only I think the default 6.25U spacebar and 1.25U mods, but I'm gonna add more cutouts for all the other options that Anticheww supports in a bit. So we're gonna use this template to make all the cutouts in the actual plate. So we're gonna add this to the design. So we're gonna insert into current design. Oh, the other thing you want to do, you want to correctly position this relative to this thing we're gonna cut. What I personally like to do is to make a cutout in this plate right where the escape key is. So we're gonna have let's make the PCB visible again. So here's the PCB. So we're gonna edit this plate. So let's put a cutout right above the escape key. That's just gonna be like a centering. That's just gonna be like a homing point, so I can correctly mate this template to this plate blank. So let's make a cutout above the escape key, capture position. So let's project this hole, and then. So the usual cherry switch cutout is 14 by 14 millimeters. So we'll just make a cutout of that size. Cool. Probably want to not make this relate to this feature on the PCB, so when the PCB gets updated, this isn't gonna break. But we'll just do this for now. Okay, so this. Now we're gonna extrude this. Do through all. Cool. That should be positioned right above the escape key. Yep, that looks right. Okay, so we're gonna use that, and then. So we're gonna do a joint between this template and this plate. So. Okay, so I'm gonna do. Middle of this line to middle of this line. I think I flipped this 180. Yep, that looks right. Okay, cool. Then we're gonna do an extrude. It's kind of gonna suck and slow my machine down, but let's make the sketch. So we're gonna project all these cutout features onto the actual plate. This is gonna take a little while. Cool. And then let's hide the template. All right, and then we're just gonna select every single one of these and do an extrude cut to make the actual switch cutouts. Just takes a little while to select all of these. It's probably a faster way to do this. This is just how I've done it in the past. And cut all the way through. And this is where Fusion starts to slow down because there's just a lot of sketch entities in this. Okay, cool. That's a plate. I guess I should probably add the bottom row feature, the other bottom row, the other bottom row layouts right now. So let's go back to keyboard layout editor. Okay. Sorry, that's for Boston. That's okay. Let's pull up Gondo's documentation. Anticheww. So we have all these layouts. We could try to support all of them, but that's gonna actually, yeah, we actually probably could support all of these. It's gonna like Swiss cheese up the bottom row a lot, but that's probably doable. But I also want to add ISO enter support, split backspace, ISO shift. I don't know who actually wants to use like a 2.75U right shift on a 65%. That kind of defeats the point of a 65%, but we'll think about that one. Okay, so actually, Gondo, if you happen to have the keyboard layout editor link for Anticheww, if you could post in chat, that would be great if you're still in. If not, I'll just make it. 'Cause, yeah, I can't find your raw KLE files. But for now, I'll just start making it. Okay, so this bottom row here. So we got 6.25U. We got. Oh, this is the block. Okay, we're not gonna have a blocker, so we'll just ignore this one. So we have split space. We have other split space. I don't know. This is always how it looked. You mean here? It's supposed to be Helvetica. Yeah, I was like, I don't know why it's like an italic. It's like an italic serif font. I don't know why. Okay, so let's not support this one because I really don't want to add a blocker to this case. Let's support split space, and then this is what Sanguine, and then Sanguine with the blocker. So we're not gonna do this one, and we're just not gonna do the ones with the blockers. So let's go to KLE and make these. Unless Gondo, you happen to have the KLE link. I'm just gonna start making this. So I guess if people here haven't used KLE, it's kind of just good to see it in action. Is it one right? Okay. Oh, this is zoomed in a lot. That's why. Okay. Sorry, I guess my stream is kind of covering that. Okay, so I usually keep the escape key because we're still using that one as to kind of reference. And then I'm gonna delete the other ones. Oh, it's super annoying. Okay, so we're gonna do split caps lock, or sorry, step caps lock. This one, I think you go into. Okay, I think you change primary to 1.5, and then secondary to 1.75. That's not a step caps lock. How do I make a step caps lock? It says, I'll investigate Python. There's a KLE already. Hold on. Okay, awesome. Yeah, if you have the link, that'll save me a lot of work. So awesome. Thanks. So as while we wait for the KLE link, let's reset Swill. How's everyone doing tonight? So if there's a Gondo in the chat. Okay, Gondo got the link. Awesome. Thanks, Gondo. So here's a KLE. So we're not going to support the blocker ones because I really don't want to add a blocker. So we're going to split. So this is the default, and then this is Sanguine. So what I'm going to do is, so I'm going to keep I guess the tilde key, but I call it escape. I'm going to keep that one and then delete the other ones that aren't changing. Let's move ISO into position. I don't really want to support 2.75 right shift, because that's also going to kind of Swiss cheese up the plate there, but yeah, let's not. Unless anyone has strong opinions about 2.75U right shifts, I'm not going to support that. Let's move step caps lock and ISO shift into place. Delete the bottom row. And then delete all the other keys that aren't changing between different. We're going to delete all the other keys that aren't changing between different options. So I'm going to delete all the alphas except for the tilde key, which I'm going to use to reference. So let's do Sanguine first. So This is split. So this is step caps lock, ISO shift, ISO enter, and split backspace. So then Sangian, and then let's delete these arrow keys. And then let's delete these for now. We're gonna go back to split space. So this is the alts for all these options. So we're gonna go into raw data, dump this into Swill's plate generator. I use Swill because I want the cutouts to remove the switch tops. I'm pretty sure AIO3s doesn't have that option. So let's make this plate template. Okay, and then let's save the DXF. So this is going to be alt template plus Sangan. Okay, so that's one template, and then we need templates for split space. Gondo says also pylon. Let's see what Gondo has to say. On the Eco2 user layer. On the KiCad file, you can export that as a DXF. True, actually that's probably faster. I just haven't done it that way before. But that actually might be faster. Okay. Eco2. Let's hide all the other ones. What does that look like? Eco2. I'm not seeing it. Oh, sorry, that's Eco1. This is Eco2. Still not seeing it. Edge cuts. I have both Eco1 and 2. Wait, is this? This is Anticheww. Not seeing it. Try both. Yeah, this is both. Edge cuts. Yeah, it's not sure. Is it items? Hidden text? No. Yeah, it's not on the layers. I'm not seeing it. Is it on on DWG? User comments. Margin. Fab layers. Oh yeah, I'm not seeing it, unfortunately. It might also just be my version Acron library or something. I think I'm on like a pretty old commit. Gondo says hold. Okay. Let me update the library. Okay, we're gonna update the Acron library then. Let's wait for Gondo's commit. Acron library. I'm gonna delete these changes. Actually, this might be referencing. I think. Okay, Gondo says give me 5. Okay. I think Anticheww might have its own copy of the library. Where is it? Where's my GitHub? KiCad files. Yeah, there's an entire Acron library folder on the Anticheww GitHub. So I'm not sure what's going on there. Actually, while that goes on, I might just proceed with the KLE method for now. So we're gonna do split space. Okay, what did I delete? That was not a smart delete order. Okay, so I'm gonna move the split space into the right place. Actually, just do all that again. Okay. Okay, so we're gonna delete this and move split space in the correct position. So this is one split space option. Excuse me. Let's dump this raw data in Swill. Then split space 1. And then let's do the other one. Cool. Raw data. Put this in the Swill. Plate generator. Draw my CAD. Cool. Yeah, so this is how I make plates, but yeah, the way Gondo suggested using KiCad and the edge cuts 2-layer, that's probably faster. Because they'll probably you can probably do all your alternate layouts at once instead of having to go in each time for every alternate layout. But yeah, let's make some templates for these plates. Create sketch. I'm gonna insert those DXFs that we just made with the plate generator. So we have Sangan. That looks right. Let's fix this entire thing. And then let's do an extrude. Done pushing. Okay. Let's see if that. Did you push on the Acron library or did you push on the Anticheww? Because I think Anticheww has its own Acron library that comes with it. And I might be referencing that. And then I had to go in and change all the KiCad references. But yeah, let's see. Was it refresh pull origin? Updated 3 minutes ago. Let's see if that works. Well, let's just make a plate both ways just to kind of show people. All products have the Acron library as a module. Okay. So that was pushed. So I need to update. Which one is this referencing? This is referencing edge footprint libraries, product specific. Acron. Yeah, it should be referencing the proper Acron. Check the repo. How do I do that? Plate branch. Okay. GitHub. I'm not great at Git in general, so let's see how to do this. Current branch origin v3. Wait, is it? Is it an Anticheww? Simple chew, pull requests, origin plate, switch branch. On discard changes here. You have to fetch, then fetch origin. I think that should fix it. Let's close this, and then let's reopen. Anticheww, this was updated at 8:37 p.m. So this should be the new files. Shoot. Okay. That's on a newer nightly. I'm on mid-August because I have a weird issue where. So this is done on the September 9th nightly. So we're both on the nightly versions of KiCad. I'm on I think early August. I've tried the newer nightlies, but it doesn't seem to play well with the files I have. It's missing all the footprint. It's missing all the pads when I open it, and I've searched the KiCad like forums and they didn't seem to say anything, so I went back to the early August nightly. So I can't open this right now without installing a newer version of KiCad, which I actually don't want to do. So sorry Gondo, we're not gonna do the. You have to fetch? No, they are not. What are you referencing? You have to set them to be seen. Okay, yeah, I just haven't looked around hard enough because I tried looking for that setting and it just. Come on, update to the nightly. I'll help you. Okay, fine. We'll update the nightlies. Because, yeah, I was working on this Boston PCB yesterday. I was adding a bunch of features, and then I wanted to use a newer nightly because it still has a bunch of bugs. Oh, shit. Is this... Okay, I'll deal with that later. Yeah, I was tried using the newer nightlies, and then I just couldn't figure out how to open the pads. So, okay, we want to take a brief detour and fire up the nightlies, or download a new nightly of KiCad. I just doxed myself again. Okay, so future advice: McMaster Car will dox you. Fusion also doxes you if you use your correct name in the username pane, because it puts your real name on the upper left-hand corner, which is why my video is on the upper left-hand corner. But McMaster Car puts it on the upper right-hand corner, so I accidentally just doxed myself. Whatever. I'm gonna delete the. I'm gonna edit the and I'm gonna delete the VOD and try to download it and post it on YouTube, or I'll just be doxxed and I don't really care. I'm Pylon on Geek Hack, and I don't know. I don't think I'm in enough drama that my personal identity being out there is much of an issue, but we'll see. Okay, so we're gonna download the native KiCad nightly. Gondo says use nightly. AIO3 says use 5.1.4. So I switched to the nightlies because the Acron library is on the nightlies, and all my Boston files are on the nightly now, so I can't go back. Better to have two computers. Yeah. I mean, I could like dual boot or something, but yeah. So let's download the latest nightly. So it's the 17th. I also have the 915 nightly. So let's throw that into downloads. That's gonna take a hot minute, so let's go back to the case. So let's see what latest nightlies have some very nice features. Okay, good to know. Yeah, there's some bugs on the older nightlies. Like every time you copy paste, apparently there's duplicate UUIDs in it. Every time you make something by copy paste, it just does not save it. It has screwed me over on the PCB for Boston, so I would like to use a newer lightly if that's fixed. All right, let's see what we can do that's not involving the plate. So while KiCad downloads, I can work on other parts of this case. Where did I? Okay, that's a plate template. This is Boston. Okay, here. This is Anticheww. So we have a basic plate. We have the top, the case top, and we have the PCB. All right, what do we want to do next? We should probably figure out this USB port situation, because right now you can't plug in a USB cable. So we're gonna make a cutout here to do the USB. So while KiCad downloads, which is gonna take a little while, let's start on this. So how do I want to do this? So let's do an extrude here. Let's make a sketch here. Then let's do, I'm on the wrong. Actually selected the top level assembly instead of the top case. So top case is here. Let's do a sketch here. So this is the aluminum version. I'm gonna do a 3D printed one also. That's probably gonna be in a different stream because this is taking some time. So we're gonna make the cutout for this USB port right now. We just have to choose some dimensions. So it's gonna be probably 14 millimeters from the center. So let's make a center line off the center of the USB port. And let's make this 14 millimeters wide. Let's center that using the symmetry tool. So then, how much of a gap do we want here? Let's do like 0.5 millimeter. Okay, and then I'm trying to not reference the PCB because the PCB step file is going to change in the near future. So I'm going to I'm going to have these reference other things. So let's do the edge of the case here. This will over constrain the sketch. Okay. Just call that 8.1. And I want to delete this relation to the USB port. So we'll just make the center line off the side of the case. Okay, cool. So that's gonna be the size of the cutout, and then we want a little bit of wall next to the cutout. So let's make this construction. Let's make these two construction, and then add another rectangle here. Or let's extend these. So how thick of a wall do we want? Let's just go to the edge here, and then let's maybe do like 1.5 millimeters. That should be plenty machinable. Oh, we're also gonna cut this out of the plate when we get to it. How much do I have until this corner? Okay, let's just move this. Instead of defining it, we'll just move this over to the start of this fillet. And that's 1.4. Yeah, that's good enough. And then this 1. Let's do 0.5 millimeter off the side of the USB port. I tend to go to like 0.5 millimeter is like kind of my go-to clearance dimension. It's a little much in a lot of cases. It depends on the machining process and stuff and how confident you are that things will fit. 0.5 millimeters is pretty loose. You can usually go down to like 0.2 or 0.3 if you're like good. I'm just gonna do this with a lot of clearance though, so it has a bit of wiggle room. Foggy says do 14 by 8. Yeah, that's a plan. I'm just extruding the walls off the side of the cutout. Actually, these shouldn't be construction lines. Okay, and then let's mirror that. See how the KiCad download is going. 229 out of 9. 20 minutes left. Okay, that's going to be a bit of time. We'll just work on other parts of the case while that goes on. So we have this for the cutout. So let's extrude some stuff to make the USB cutout. Let's hide the PCB. And let's... Okay. Dang it. Okay, let's hide the plate also. Okay, this is one of the things in Fusion that annoys me, is that I'm trying to select this profile, but just selecting this the sketch off an invisible component. So we're gonna hide the sketches on the plate too. How is it still selecting this? What the fuck? Okay, oh, that's a general little sketch. Okay, there we go. Where am I? Okay, here am I. Let's just do it all the way to the top. Okay, and then we're gonna have to extrude a rectangular cutout out of this also. So we do a rectangle, start in this corner, and in this corner. Do a collinear here. And how deep does this need to go? Okay, how much room does that give me relative to the USB port? Okay, that's way too much. Okay, actually normally don't do this, but because this extrude cut only covers this part of the rectangle, I'm not going to undo that. I'm just going to do another extrude to move that face back up. Normally, I don't advocate doing multiple extrudes, but here it's actually just easier. So 14 by 8. So where's the center of the USB port? There's not an easy way to grab that dimension. Okay, well, let's extrude this back up. Oh, actually, fuck. Okay. What you want to do is actually... So you have the extrude that goes up to the port, and then you have the extrude, which should be a lot lower, that goes up a bit lower than that, so that there's room for the edge of the USB cable. So what we're gonna do is make a new sketch. Make it a rectangle. Here to here. Let's just do 0.5 millimeter off the edge of the USB port. So how much distance is that? So that's 6.6 minus half, so 6.1. Okay. This is gonna be a pretty thin wall. 0.9. Yeah, that's really thin. Actually, I can make it a little thicker on this side, so I'm gonna do that in a little bit. And this can go up a lot. So 14 by 8. So I'm pretty sure, I think this is 3.2 thick. That's usually what a Type-C M12 is. 3.2, okay. So do some math. 3.2. What's the okay, so 1.6 off the center. So we're gonna do this. So Foggy said 14 by 8, so we want half of that, so 4 millimeters. So 4 minus 1.6 is what? 2.4. So I want 2.4 from the bottom of this edge. So I think this was 6.6. So I can do math, just this is faster. So 4.2. So we're going to extrude this up by 4.2. Okay, that's the bottom half of the USB cutout. Let's make this wall a little thicker because 0.9 is cutting it. Actually, there's going to be a fillet here. That might be okay. Well, we're going to add some fillets here so that this is actually machinable. So Okay, that's so 3mm fillet is a bit large. Let's see what I can do here. How large of a fillet do I want? So the CNC machine is gonna have a 1.6 loaded for this operation, but that's on a separate operation than what's gonna be used for the bottom side of the case. I really want to make this fillet 3, but I don't think we have room for that. Could dog bone this. What we should do is this first extrude needs to be bigger. So trying to get some more room so I can use some larger radii so the machinist doesn't have to use like a 1mm end mill. So let's make this bigger. So I'm going to move this line over a bit. So or cut from the side, not much you can do for this tight. Yeah, I just want to avoid adding the setup to cut from the side. Like, yeah, you can have the end mill come in from this way, but like a lot of machinists will hate you because this is a very like not rigid way like setup. I guess you could do that before you cut the rest of the case, but I'm gonna try to avoid adding a setup, so I'm gonna try to do it from the bottom. So I'm gonna move this over. So this has a coincident here, and that lets me move it over. So let's make this wider. Let's go to the start of this. Let's do right here. Let's do coincident to this point right here where this circle starts. Oh, actually, that actually fucks up this circle, so we're gonna do a little bit less. Let's do like, okay, actually cut that first, then from the flat side. Yeah, that's an option. I just want to avoid that setup because we also have like this USB port is also kind of right in this edge is also kind of right in the middle of this USB port, so this is kind of ideal already from just being able to do that cutout from the top and bottom, or just from the bottom. So I got a full slab of aluminum to hold in the vise. Yeah, it will be more rigid if you hold it that way. It's still an additional setup. That if I can avoid it, I'm gonna avoid it. Okay, so this is the 6mm end mill. So let's do it right just past that. Maybe like here. Actually, we'll just do it right at the edge. Okay, I'm gonna do a tangent here. Tangent to, oh sorry, that's perpendicular. Tangent from this circle to this one. How's the KiCad download going? It's about halfway there. Okay, so how's that not fully constrained? Oh, okay, that's why. Need to make the circle equal to the circle. Cool, so now there's more wall there. Then we can make this cutout actually wider, and then that gets us room to make this fillet a bit bigger. So let's make this cutout wider. Sorry, that's the wrong sketch. I think this is the sketch I want. Okay. So let's do like a 16. That seems like a pretty reasonable wall thickness. Actually, is that? That's a 1.3 wall. That's doable. Okay, so let's see how large of a fillet we can do here. It might just be a 1.6. Then how much room does that leave for the cable? 12.8. That's kind of pushing it. You have a little room where before the cable. Actually, this might work. Let's go measure a USB cable. Where's my nearest USB-C cable? The one on my keyboard. Okay. Let's see. This cable is 12.1 wide by 6.46 tall. Okay, it's a pretty small cable. How much? The question is, how much does the edge stick out from? Okay, so here's my prototype Boston. One of 3. So how much does the edge of the cable, like this molded plastic part of the cable, when does that start relative to the end of the female USB-C port? It's probably about 1 millimeter. Okay, so I actually might have the room to do this. So okay. Yeah, let's just do some test sketches here. So just to see if the port fits. So we have our USB-C cable end. Make this about 1 millimeter off. Is the cable gonna hit the sides? Let's find out. You got 1.5 millimeters from the USB-C port face to the plastic cable housing. Yeah, I bought it was about 1 millimeter, so that sounds about right. Excuse me. I'll just do 1 millimeter just be safe. Yeah, that's gonna clear. Okay, so we're good. So we can do 1.6 millimeter fillets here. A little smaller than I like, but it's definitely not. That's not a huge pan to cut. Especially this is kind of a shallow pocket, so that's definitely doable. So this will fit. Just suppress a sketch because we know it'll fit now. We're gonna add some fillets. This is kind of weird, so let's add a 3 millimeter fillet here. That should be fine. And 1 millimeter more where it will connect but not fully click. So sorry, so Foggy, you're saying there's 1.5 millimeters from the USB-C female port to the plastic cable housing. Okay, and 1 more millimeters more where it will connect but not fully click. Okay, so I think that means that I have 1.5 millimeters, but I did this with assumption of 1, and it looks like it'll fit. So yeah, let's just go with that. Let's add a fillet here. Let's add a 3 millimeter fillet here, and then let's fillet these sharp corners. Let's do 1. Then aesthetically, it's not ideal to fillet these, but I'm probably. Do I want to fillet this corner? It's gonna look worse, but it's gonna prevent cuts and blood. So don't. Let's just add a chamfer here. We'll just call that. So I think let me adjust this camera a little bit. Okay, cool. So what are we here? Okay, so let's. Are we done with the top? I think we are. So AIO3 says 1 to 1.8, where 1.8 will be barely touching, not fully clicked into place. Okay. Well, I use 1, so it should be fine. But yeah, thanks for that, Foggy. Let's see where we're at. Okay, so let's add a fillet here, so that this sharp corner kind of matches more with the edge of the USB port here. What's this radius? 1.2. Okay, let's just do a 1 millimeter fillet. This is gonna. Okay. So where's KiCad gone to us? It is still downloading. It says 10 minutes left. So we're doing other things on the case while we wait for KiCad to download. Actually, what I should do while I'm waiting for that is uninstall my current version of KiCad, because that also takes a while. Putting a lot of write erase cycles on my SSD, just installing and uninstalling different nightly versions of KiCad. But yeah, let's do it. Uninstall KiCad. Oh, KiCad is currently running. You must close. All right, let's close all the KiCad. This is a read only. Let's close all the KiCad so we can remove this current version of KiCad and install the new one. What else do I have? I have this. Okay, this. Cool. What's going on here? Save changes. Sorry, I have a second monitor that you can't see on this main screen. Your internet speeds suck. Yeah, I don't. So I have 100. In theory, I have 100 megs down. And I'm only getting like 13 megs. It might be their server. It might not be my fault. As far as I know, the server might be in. I think the server is in France. Like that might be part of the reason. The server the Windows nightlies are hosted on are far away. Anyway, so what was it doing? Yeah, I was gonna uninstall the current version of KiCad. Control panel, uninstall. It's still running. I thought I closed everything. What do I have? Oh, I think sometimes PCB new doesn't close properly. So let's go to Task Manager. It's alphabetical. Okay, it is 2 PCB new instances that I have no idea where that's from. Also, out of 3 mirror KiCad, there's only 1 fast. Okay, that's good to know. I don't know if they have the nightlies on all the mirrors though. So, okay, I think I uninstalled every KiCad instance. So let's uninstall KiCad. Yes, I want to remove everything. So while that goes on, download's still happening. Okay, back to the case. It's gonna fill out these 2 corners. Let's just do. So this is gonna be done with a ball-on mill most likely, because how it's held. So this is kind of like looking down from the CNC, and if you want to make a fillet on this like axis, it's probably when you're done with a ball-on mill, or you just run like a square end mill or back and forth a lot of times. But ideally, it's done with a ball-on mill. So ball-on mills only come in certain sizes, so we can't just make this fillet an arbitrary dimension. Well, you can. It just takes more passes, and your surface finish isn't as good. But we'll just do 1, just because then you can use a 2mm ball-on mill. It's a pretty shallow cut, so the fact that that's a pretty small tool shouldn't matter. Do I want to fillet this? That's actually tempting, because we already have a 1mm fillet here. You know what? Let's fillet this. Yeah. Okay, cool. I think that's all for top case. So we got the USB-C port cut out. We got, I think what else is on the top? I'm not gonna add a logo to this or anything. What else do I think that's it for top case. So then we probably want to start with the middle case. Actually, let's add a chamfer on the bottom. Just so people don't cut themselves on these 2 sharp corners. It'll probably be a pretty small chamfer. Let's do like 0.3. That went all the way around. And then could do a chamfer on the inside too. We want to, yeah, why not? We already have a chamfer tool loaded on the CNC, so let's do 0.3. And then looks pretty good to me. Cool. Let's start the middle case then. KiCad is still 30 seconds left. Okay. Well, that's enough time to start the bottom case. Okay, so the bottom, how do I want to do the bottom? So we need to give enough clearance for this PCB. So that'll kind of determine the thickness, and then we probably want to do some bump-ons also. All right, well, let's start with the bottom. So how do I want to start with the bottom? We're going to make a new component. Sorry, not new drawing, new component. I'm going to call it, this actually might be a middle because of how I want to do this case. So actually, let's name it the middle. Actually, let's call it the bottom. We'll call the weight something else. So we standard internal from bodies. Okay, right parent. Okay, so let's start making the bottom. Oh, that chamfer actually is annoying because here. Okay, we're gonna add that chamfer later because that makes making the bottom harder right now. So we're gonna go back to the top and delete these chamfers. We'll add them back later when it's easier to do so. But right now, those chamfers make it harder to start making the bottom. So this sketch here, I think everything's projected. Okay, so let's extrude this. So how tall do we want to extrude this? So let's go for how much clearance do we need on the PCB? So there are these RGB LEDs, but I'm just gonna make an aluminum case, so they're not really gonna be visible. But we probably want to clear this by, let's do 4.5 millimeters off the bottom. So the minimum clearance you really want is like 3. That's if you have like a really rigid plate. So the pins from the switches will generally stick out about 2.5, and then all the screw heads that hold the stabilizers in stick out by about 2 millimeters off the top of the PCB. And then you want it a little bit just to account for board flex. So let's do, so yeah, like 3.5 or 3 is about the minimum safe one, but let's do 4 if people want to use like a flexi plate. So let's extrude. So how much do I have right now? Right now I have 0.9. So 4. Okay, I shouldn't be doing arithmetic this simple on a calculator, but whatever. We have technology. So this is 3.6. Yep. I can still do arithmetic. So I'm going to extrude, new case, 3.6 millimeters. And let's check that that gets us 4.5 from the bottom of the case, or the bottom of the PCB. Yep, that does. And then I'm just going to double check a couple things that the distance from the plate is also correct. So from top of the plate to top of the PCB should be 5 millimeters. Yep, that's correct. And then, cool. Okay, so back to, I think KiCad should have downloaded now. So let's install that. Yep. Wow, setup is loading. Installer's already running. Oh, that's for the uninstall. The uninstaller is still running. Just trying to also not further dox myself, but so okay, let's just run the installer again. Okay. We'll just do it from Task Manager. I don't want to minimize all these windows because I've already doxed myself a couple times on the stream, and I don't want to do it more. Okay. KiCad installer. What's it called? Okay, fuck it. We'll just. Here's one. Okay. There we go. Yes. When all these. Okay, 5.7 gigs. So that's gonna take a couple minutes to install. So let's get back to the case. Okay, so we started this part of the bottom, and then we're gonna do the actual like floor of the bottom case. So let's do that. I'm gonna make another sketch and then another extrude. Project. We're just gonna sort of project this entire outline, and then what else do we want? We need to fill in a bunch of gaps. So actually, the other thing, does that give like the correct USB port? Okay, we'll fix that later. Okay, so let's make the floor of the case. So extrude. I think that's everything I want. So how thick should the floor be? Let's do 2.5. That should be pretty machinable. Okay, that's the bottom of the case. Looks fine so far. We do. I think we had to make these holes larger because these are. Yeah, this is a tap diameter, and we had to make this the clearance diameter. So that's one thing we have to do. Excuse me. We also had to fix this USB thing. So we had to like do an extrude here to raise this. But yeah, that's the beginnings of the bottom. Let's see how the KiCad install's going. Oh, that was fast. Okay. Usually takes me a lot longer to install KiCad. Okay, if Gondo's still on the stream, let's fire up KiCad. So we want the latest Anticheww. It's GitHub Anticheww. Anticheww. Sorry, HR Polar, right? Okay, I think this is probably a spammer, so I'm not gonna respond to that. Anticheww KiCad project. Also, I'm probably gonna have to stop the stream around 9:30 or so. Okay, yeah, KiCad project. Okay, so PCB. Okay, so this is where all the pads aren't visible. So yeah, Gondo, you're gonna have to help me here. How do I turn the pads on? Okay, so Gondo says okay. So on the right column, yes. Click objects. Yep. See the eye icon? Yep. Oh, okay. Nice. Awesome. Thank you. That makes sense. Okay. Let me see if that opens Boston too, because that let me open the Boston PCB real quick and see if that works. That's the wrong folder. They are set to unseen. Okay. This is the magic that lets me continue using the latest nightlies and not have to deal with bugs from old versions. Objects. Was it through pads? No, wait. Sorry, what was it again? Okay, perfect. So here's the Boston PCB and the latest KiCad Nightly, and it looks great. Awesome. Okay, so we're gonna make the plate. Let's go. So we're going to the plate. So it should be on the edge cuts layer. Let's hide everything else, except edge cuts or at edge comments or eco or whatever it stands for. Okay, that looks good. How do I export this? Oh, this doesn't have the switch cutouts. That's the other thing that I was trying to do on this plate. Well, let's make a plate this way also. We'll just make plates both ways. So it's on eco 1. Then was it? So I need to export the DXF out of this. I do not remember how to do this, but I think it was plot. Oh wait, I think you change this to edge cuts and then use that to export a DXF. Okay, I want to export a. No, this is export SVG off edge cuts 1. Oh, file plot. Okay, thanks, Gondo. Plot. I don't want a Gerber. I want a DXF off eco 1. I still probably want some on edge cuts. Not eco 1. Okay, awesome. Yeah, thanks, Gondo. So yeah, let's start this output directory. Let's throw it into the Anticheww case. Select folder. Yes, plot. Checking zone. Okay, shouldn't need to do that. Cool. Okay, so DXFs were made. Let's open those in Fusion. New design. It's gonna be KiCad base plate template. Anticheww plate files. Okay, yeah. Then insert DXF. Eco 1. Okay. So select DXF. Oh, sorry, I just started a sketch. I always forget. So when you import a DXF, the easiest way to do it is when you're already in the sketch mode. So insert DXF. Eco 1. Is it frozen? Okay, just taking sweet time. Yeah, okay, yeah, this is just gonna take some time. Okay, so Fusion froze. Okay, while this happens, let's what do we want to do? Yeah, well, okay, all the case design stuff is in Fusion, so can't really do much else. If people have questions or like case design stuff, feel free to ask right now or just anytime. While I wait for Fusion to unfreeze, hopefully this isn't a hard crash. It's using most of one thread. I have hope that this will recover. It'll just take a little bit of time. Okay, so while Fusion's frozen, people have questions, comments, concerns. I can talk about things. I could actually. There is some review work I need to do on this Boston PCB. I was planning to send it out tonight to JLC. Yeah, this is still frozen. So I might just inspect this real quick, because I thought I saw an unconnected thing on this one. All right, well, that's gone. Just run DLC. So yeah, I'm temporarily switching to Boston. Foggy says F. Is this an F? Okay, it's not F yet. So we're not gonna post this into the Keyboard Outlier Discord. Okay, so we have a lot of nested features here, but this is a pretty complete plate. It just doesn't have the cutouts for removing the switch top, but yeah, we can use this. And then so I'll make a plate both based off this one, and this one's actually kind of better for FR4. You kind of don't want the cutouts, but we're probably gonna do a metal plate. I was planning to do a metal plate, and then well, this is so frozen. This is freezing again, but so I'll make a plate both ways just to kind of show people how to do it both ways, and also because the KLE method gets the cutouts for the switch top removal. Yeah, while the sun freezes, I'm gonna take a look at Boston real quick. There's a warning. Oh, there is an unconnected item. What? Okay, there's a 3v3 here. Actually, this might be. There's some weird KiCad bugs with like duplicate UUIDs. So I think there's a repair board tool. Tools repair board. Okay. But yeah, there's unconnected item. This is concerning because there might be other deleted like traces that I was not aware of. This also did not show up on DRC earlier, so this is kind of concerning. What else am I missing on this? Okay, is Fusion unfreeze? No, Fusion is still frozen. Okay, I'm probably gonna cut the stream at 9:30. So in about 12 minutes. We'll see if this unfreezes, but yeah, there's a lot more design work to be done, so I'm gonna see if I can stream later this week. I could probably stream tomorrow night also, probably also around 6:30. And then yeah, maybe it's Friday and Saturday. Yeah, I'll try to figure out when I can stream later in the week to continue on this. Okay, it unfroze again. Actually, let's do the plate later because it seems like this tends to freeze Fusion. So let's go to. Okay, let's go back to this. So this is where we're at. Okay, so this is the bottom. So what do we need to do here? We need to enlarge these holes into clearance holes, because right now they're for the tap jewel diameter because it picked off of these holes, which are at the tap jewel diameter. But we need to make them larger. Let's do counterboard holes on these. Okay, so let's start with enlarging these holes. So this is matter making sketches again, and then using the hole tool. So we need to choose a hole size. So create. So this time I'm gonna try to not dox myself while browsing McMaster. So let's see how large M3 screws are. Okay, let's see what screws we want to use. Let's make this bigger. Socket head cap screws, metric, M3. How much room do we have here? I'd be able to use like a regular socket head cap screw. 6.1. Yeah, let's just use a regular. I'm debating between, so there's a couple different sizes of screws. There's like a regular socket head cap screw, which is like a narrow. This has like a narrower head and is taller, and then there's a different one where it has like a wider head, but it's narrower. I usually use the second kind. The issue with the second kind is the hex. The hex is smaller, and if the hex is smaller, then it's easier to strip. Because a normal M3 socket head cap screw uses a 2.5 millimeter hex, but if you go with the wider head option that's thinner, then it usually uses a 2, which is actually noticeably easier to strip. But the wider head is nice, so let's use a regular one. It's easier to get. So we'll just use a plain. We'll use a normal whatever DIN 912 socket head cap screw. An M3.5, so it's a 5.5 millimeter diameter head by 3 millimeters tall. So we're gonna use that for the counterbore dimensions. So let's make a hole. Let's see. Okay, so actually let's hide the bottom case for now. Sorry, the top case. So make a hole. I'm gonna make an M3 clearance. I have these memorized, but I'm just gonna do it the proper way through Fusion. So you're gonna select clearance hole, and then you select the head size, which is M3, and I should set a 3.4 millimeter diameter hole. And then we also want to make this counterbore, so we're gonna select the counterbore option. So for counterbore, so we got our screw dimensions earlier, so it's 5.5 millimeters diameter by 3 millimeters tall. So you want to make it a bit bigger, so you have a bit of wiggle room. I usually add a millimeter to the diameter, and then do like half a millimeter height. So we'll make the counterbore. Oh, it is fixed dimension. Oh, okay. This is M3. Why can I just manually edit these? Normal, so I get a cap screw. It's only got 3 millimeters tall. I want to make this deeper is the thing. Can I manually enter this? Fit normal. How do I edit these dimensions? Flip direction, counterbore. Alright, I'm just gonna punch in these manually. Okay, so 3.4 millimeters diameter for M3 clearance. Make just 3.5 millimeters tall for the counterbore by 6.5 diameter, and then we'll do a through all for this. Okay, looks good. And we'll just make a bunch of these. Okay, so those are counterbore holes. What else needs to get done on the bottom? Let's fix this USB port. So this needs to go up a little bit. So we need to do an extrude here. Okay, so let's hide the so we want the USB port visible, but not the rest of the PCB. Whatever. Let's hide the plate. Okay, so create sketch. Oops. Okay. So we want to raise this part. So let's make it a little bit wider so that this thin wall here isn't as tall. Okay. How do I want to do this? Yeah, this is fine. Okay. Let's do 2 millimeters. Okay, that should be enough to let me extrude this. So how much do we want to extrude it? 1.29. Let's give it half a millimeter clearance. So let's do 0.79. Just do 0.8. And then let's see. So Foggy said 14 by 8 for the USB port clearance. Let's see if that's still true. That's 6.10. Okay, this needs to be Oh, we actually want to extrude this. Okay, we actually want to extrude this part down so that there's more clearance for the USB connector, and then we want to extrude this part up so that there isn't a huge gap between the port and the bottom. Okay, so how do I want to do that? Let's edit this earlier extrude. So just add this line here so that it's limited to the portion behind the USB port, the portion below the USB port. So let's edit this extrude. Okay, and then this actually wants to go down. So to get the 8 millimeters of clearance that Foggy suggested, so we need to extrude it down by 1.1. So negative 1.1. Okay, cool. This looks good. Let's add the fillets. So I think it was 1 millimeter on all of them. Cool. That looks good. It does bother me a little bit that so you can see the seam doesn't really line up with the middle of the USB port. That would be nice. I just don't really want to go back and change that right now. It's also not, I mean, you're not really going to see well, you can kind of see the seam here. Whatever. We'll let it be. Okay. The bottom is pretty close to being done. Oh, we should add the chamfers between the seams. So, okay. So we're going to talk about seams real quick. So, the thing with seams. So right now you can kind of see this plane and this plane are flush. This plane and this plane are flush. This plane and this plane are flush. This looks great in CAD, okay? It results in a minimally visible seam. But in reality, it's actually really bad. So where's my other Boston prototype? So in reality, when you have seams that are perfectly flush, the real world is imperfect, and they're going to be a little bit misaligned. So the problem is, okay, is this visible on camera? Okay, so this is a Boston prototype. This is an earlier version of the aluminum case. This one also has flush seams. In reality, these seams are not flush, and it's really, really bothersome when you take your finger and you just run across the seam, because you can just feel like this tiny lip where it's not aligned, and it's really, really bothersome. Like you just take your fingernail and just run it, and it just catches on the seam, and it's just, like you can't even hear it. Like that's all the. I guess this is an ASMR video now, but this is okay. No, we're not gonna do ASMR, but this is. You can even hear the misalignment. So this is not good from a fit and finish perspective. So how can you fix this? So you can either tighten up your tolerances a lot so that in reality these actually all line up. That tightening up tolerances costs a lot of money, so we're not going to do that. Foggy says the only way for flush is to use a line pin, really precise, and do final cut with both pieces bolted together. Yeah, I was thinking about that's what I was thinking about doing for this, but then I just redesigned it so that the seams don't line up. So then serialize them. Yeah. So you have to make if you machine it both together, you'll get a perfect seam, but then that bottom will only ever go with that top, which is what Foggy means by serialize them. So the lesson here is don't do perfectly flush seams. So you want to add a feature here so that the user doesn't want to take their fingernail and do this, because this is really bothersome. And if they're paying $400 for a keyboard, then they're going to complain in the group buy thread that this is bad fit and finish. So there's a couple ways. I mean, so yeah, so what Foggy suggests involves tightening up tolerances, and it's an option. If you really want a flush seam, you can do that. It will just cost you quite a bit of extra money. The other way to do that is you can make the seam not flush, so you can make this one stick out a bit more. That's kind of what I did on the redesign of Boston. So you can see here, so this is the redesigned aluminum version of Boston. I added an overhang so that you're not that way. So because they're not aligned, any slight misalignment isn't going to be noticeable because there's already this big overhang here. So how we're gonna deal with that on this one? What I'm probably just gonna do is just add a big chamfer that goes all the way around so that they're so flush, but there's just gonna be this huge gap in between that if you're gonna run your fingernail over it, it's already just gonna be like there. So they're not gonna really notice any misalignment. So let's do that. That's probably the last thing I'll do on the streams tonight. I actually so I'm reviewing the Astro 65. So was it Clonentropy is designing another 65%. Called the Astro 65. I agreed to do some review for him tonight so that he can get this cases sent out. If he's okay with doing that on the stream, I might do that on the stream. But if not, I will probably have to cut the stream. But yeah, let's add those champers for now. So I'm gonna go back to case top and add those champers. Let's isolate this. Let's do like a 1 millimeter chamfer, a pretty big chamfer, so that any misalignment is well hidden by the gap that's formed. Yeah, let's do a millimeter. Let's see how that looks. Okay, that's a big chamfer. I think these are both. Yeah, these are both a millimeter, so that's also symmetric. Excuse me. And then let's do that again on the bottom. So modify chamfer. Let's do a millimeter. So now 0.5 is fine. 1 is kind of big. Okay, yeah. Well, let's see how this looks. You're probably right. Yeah, that's kind of big. Let's see how this. I mean, it's an aesthetic, but maybe 0.5 would be better. Let's see what that looks like. So let's edit these chamfers to 0.5. Yeah, I'd say that looks better. Okay, thanks, Foggy. Yeah, that's definitely better. You can also, instead of doing a chamfer, you could like just have like a square profile and just have like a square seam. Though then like dirt tends to get trapped in there, so that's not great. But let's do this for now. Okay, so it's 9:32. I'm not sure if Clonentropy is even watching the stream. Oh, we're down to 2 viewers. Okay. Yeah, I don't know if I have his permission to review his case on the stream. He does say he wants it brought up at some point, but yeah, I need to do that. So we'll continue on this later in the week. So let's save this. Oh, what happened here? Oh shit. Okay. That's a problem. Okay, we're gonna have to fix this later. This means I'm gonna have to switch to. Oh shit. Okay. Millimeter. Okay, I'm gonna have to fix that. And then what else? So I had to fix that. I'm probably to make this taller just to get more room for the counterbore. And then what else do I want to do? Need to add a chamfer here, and then there's gonna be another piece on the bottom so that right now this is totally flat. I know Norbauer likes flat keyboards, but like there's like most people want an angle, so I'm gonna design a third piece that like here that kind of sets an angle. But yeah, it's 9:33. I need to start reviewing. I need to do some review work for Clonentropy's Astro 65. So I'm probably gonna end the stream right now. Yeah, thanks everyone for watching. The 2 people who are still on, I'm guessing Foggy's one of them. Yeah, this is my first time streaming on Twitch really, and I think it went pretty well. If any feedback, let me know. I don't actually know how to do a raid because I'm really new to Twitch and this whole interface. Who's streaming right now? So I'm not going to do a raid because I don't know how to do that, but I'm just going to suggest people to follow. Minterly's on. Okay, let's see who's on. Minterly, Mex on deck. I don't know if I think this is a keyboard stream. Existentially yours. Bono Bills. Yeah, so there's a bunch of keyboard streamers online right now. I'm gonna end the stream. I'm not doing a raid because I don't know how to do that. But yeah. Thanks everyone for watching. I'm gonna continue later in the week. I'll post on Discord when I expect to be continuing to work on this case. So I want to finish up this aluminum one, and then I want to start doing a 3D printed FR4 one because that'll be a lot cheaper and probably a lot more accessible to more people. As far as prototyping, I'm I probably won't get this prototyped because I'm personally not really into 65%. It's just I know it's a really popular format right now. So I just want to make an open source design, but I don't really want to pay like 300 to get this prototyped right now. But I'll definitely publish all the files on probably GitHub. And then I might prototype the 3D printed version, but I don't really want to pay for a CNC case right now. Yeah, there's still a bunch of work to be done. So yeah, I'll probably stream tomorrow night. And then I'm probably Friday, Saturday, and Sunday. Maybe Monday and Tuesday, though I'm starting a new job next week. I have this Fusion license until next Tuesday. Yeah, Foggy says, okay, thanks for today. Yeah, good stream. Yeah, thanks, Foggy. I definitely appreciate people watching because this is my first time really streaming on Twitch. And having even just like a couple viewers it helps. It's really nice that the things I'm doing are being received. And that I'm not just kind of streaming into the void. So I definitely appreciate everyone for watching the stream. I'm gonna cut the stream. There's a bunch of other keyboard streamers on right now. Recommend going on to one of them. Yeah, and thanks everyone. And yeah, I'll continue this later in the week. So let's cut the stream. All right, night everyone.